I'll pass it back once we get the streaming working. One moment. All right, we should be live now.
Great, thanks.
Thank you, Ben.
All right, I guess we can start. So welcome, everyone. Thanks for coming to the Splash and Doctoral Symposium 2020. And apparently it's also the ECUB Symposium because strange times we find ourselves in. So we moved the ECUB Symposium and merged it with the Splash Symposium here. All right, so welcome from us as the organizers. If you don't know what we look like, that is us, basically. Here we have Matthias Hauswirth, we have Yvonne Cody, we have Nafise Naskandari, we have Chang Song Tang, and we have me, Philipp Schubert. So, and we are basically, we three here are the ECUB organization committee, and Matthias and Yvonne are the Splash Doctoral Symposium organization committee. All right, so what is it all about? So thanks to our academic panel and also to the invited talks and all the reviewers that reviewed the submissions of our authors. And it will definitely help, and that is the intended goal, to help the next generation of researchers. This is the possibility, or the Doctoral Symposium enables the authors to get some feedback from top researchers in the field, and also, of course, to get to know the conference drill. So how does it work to participate in the conference? Because most submissions to the Doctoral Symposium are junior submissions. And this is a great opportunity to get to know how does it work participating in a conference. They are able to get some feedback on the research. So it's a pretty good opportunity. So to manage the questions and the feedback here using Zoom, we have a special, some special task, basically. So, and this also was applied to all the other Splash sessions so far. So if you wish to ask a question or if you wish to give some feedback, please in the Zoom chat type ZQ for asking a question. And then you can unmute yourself. The session chair will come to you, and then you can ask your question or get some feedback. Otherwise, we would just talk over each other, and it would be pretty bad, and we couldn't really give some good feedback. You can also ask a silent question. Maybe you have some noisy environment, I don't know. You can also ask some silent question by typing SQ, and then the session chair will ask your question for you. That's also an opportunity that we can work with. And once again, thank you very much for the academic panel and also the invited speakers who made some time here and also some time commitment here by giving some very interesting talks. So I'm very much look forward. And also, I really feel that the talks by the invited speakers will be very helpful, especially for PhD students. Ben Herrmann, for instance, is giving a talk on how to self-promote as a researcher, which in our times is also very important, not to get lost among all of the many researchers. Then we have a great talk, I hope, by Doug Lee as well, who is going to talk about how to structure your PhD. And then we have a talk by Alistair Donaldson, who talks about a recent project that they did at Google. So if you wish to go away from academia after your PhD, if you wish to go to industry, that might also be interesting how things work at that larger companies. Yeah. Other than that, I would say let's get started. So have fun. And I would now hand over to Michael, our first speaker.
Yeah. Hello. I have to share my screen, right?
Yeah, that's true.
So, is it sharing now? Do you see it?
Yes, now it works fine.
Okay. Yeah, then hello, I'm Michael Schlichtig, and I want to talk to you about improving the user experience of static analysis tools. Static analysis is used to analyze code before the runtime, so without executing it, and to find errors, bugs, and to check for properties if they hold. And so it's really useful to improve your code quality. Yeah, and I first want to talk to you about why developers may not use static analysis tools. Then I want to come to my project idea, how to address this, talk a little bit about the project plan, and also first research questions, how to evaluate the prototype that I'm thinking of. And I want to finish with an outlook of future work that I have in mind based on the prototype. Yeah, so static analysis tools, there is a lot of research what developers need and why they may be not used so much as they should be. And in this figure, there was an empirical study where developers were asked what they need. And yeah, I marked this here. A lot of the wishes were usability related, and from the other top wishes, it was related to the precision of the analysis and also to the performance. There's a lot of research going on, and there exist many tools tackling the precision and the performance. And I think it's really worthwhile seeing also how many usability issues or improvement possibilities there are to tackle this. And yeah, with a colleague together, I'm performing an analysis on a lot of static analysis tools which exist there. And I brought some examples. Those were just two CLI tools that I looked at this week. What you can see here, can you see my mouse? Is that you just receive a list of the findings, typically in a CLI tool, oftentimes with the location, and then some message, which might not give too much information. And also using a CLI tool means that a developer has to transfer the results to their development environment themselves. So this can be really cumbersome. And so there are luckily a lot of IDE integrated tools and others that use browser or whatnot that do this better. I brought you here CogniCrypt, a static analysis tool that focuses on the correct usage of cryptographic APIs. It's the static analysis tool that I started working on this year. I joined the development team, and it is an Eclipse plugin in this case. You can see in the bottom part, there's an own view for the statistics. So for the results of the static analysis, the typical part of the location, and then also some information about the error or the finding. And in this case, CogniCrypt shows which cryptographic usages were found and deems them to either be secure or secured on here or insecure. And you can also double click them, then get only directly the connection to the code. And I guess we are all developers in some kind, so this seems to be a lot more usable. However, there's still a room for improvement. The explanation of the errors could be improved. There could be more information, and so yeah, there's some work to be done also by us. Another example that I found really interesting, I want to talk about some takeaways here, is Google's Tricoder. Google has this large code base, so really big, and they have their own static analysis tool, Tricoder, which they integrated at code review time in the build process. And they do this because it's really important to have a workflow integration of static analysis tools, and they found out that developers are much more likely to fix a bug before the code is submitted. And yeah, so in my case, I do believe that using a tool that is integrated in the IDE really would help more, because the developer already gets feedback during development time and not just in code review time. So I want to address static analysis tools a little bit more early. And the other really interesting thing is what they define as effective false positives. So false positives are reports by the analysis which are incorrect, and a high rate of false positives is reported by developers to be very distracting, and one of the main reasons why they don't use static analysis tools. And an effective false positive is when a developer perceives a feedback, even though it's true positive, so a correct report, to be false. For example, because there's not enough information given, there's a bad explanation so that they don't understand it. But this leads to the developer perceiving the tool to be having high rates of false positives, and can lead to them not using it. So my main takeaway here is that for static analysis tools to be used, there is needed, the workflow integration is needed, they need to be well usable, and also this needs to be part of the perception of the developers. How the developers perceive using the tool is really important. Again, this is the last part of why developers may not use the analysis tools. There's another study on developer requirements for static analysis tools and recommendations on how to develop one, how to design one. And there are two things that really are striking out for me. There's one requirement in the developers' work life. It's time constraints. Developers often do not have much time in their workday allocated to fix bugs, or they have meetings, so they might have a few minutes in between to work on this. So that is one practical aspect. And another thing is using the developer's knowledge. Developers have also different levels of experience. And so my idea as the takeaway from this is it would be really neat to have a recommendation system in a form, for example, using the time constraints that a developer can say, I have 10 minutes. And so, then the analysis or the interface of the analysis should ideally say, hey, here, these are errors that could be fixed within 10 minutes, probably. And this could improve working with the results or with a static analysis tool for developers. Another point is the explainability part. So that results need to be well explained. And there was another study on explainability challenges of static analysis tools. And especially last 3 points were really interesting for me. And having a specialized user interface. And so my idea is to tackle static analysis tools from the point of using the results of a static analysis, and that they need to be well presented and in a form of, most likely you need a new tool or a user interface that is IDE integrated, so that developers get feedback during development time and can also receive recommendations on what to fix, for example. So I want to build a tool with a specialized user interface providing these features. To do this, I intend to use Magpie Bridge. Magpie Bridge is a tool that helps integrating static analysis tools into editors. On the top, you see many editors like Eclipse, IntelliJ, Sublime Text. They all support the language server protocol, and Magpie Bridge uses this. And so a developer of a static analysis tool only needs to integrate their analysis tool into Magpie Bridge, and has then easy integration into many editors just as they need. Using this, I want to adapt or modify Magpie Bridge to add my specialized user interface there. And the specialized user interface, as I said, should contribute the recommendations on what to work on, use the developer knowledge, feedback from the developers. And also one idea I have there is having a filter mechanism. One approach that is already presented is Alethea, where they use the machine learning approach to detect false positives in static analysis results, and by omitting the false positives, they improved the precision and therefore had lower rates of false positives. This might be one way. But the other thing is static analyses come with guarantees of soundness, for example, and to not change those, I assume it might already be enough to just, for example, change the order or the priority in which the analysis results of errors or warnings are presented, so that warnings that are deemed to be highly likely to be true positives are presented first to the developer. So when a developer starts working on fixing issues, they will work on many actual errors in the beginning and perceive the tool to be very precise. I wanted to tell one thing. I hope, as I want to use Magpie Bridge, that this approach works to be and will be generally applicable. But for the static analysis tool, in my case, in the prototype, I plan to use CogniCrypt as I'm working with it already. And I gave this tool prototype project the code name RUInBugs, which is an acronym for Recommendation User Interface for Next Bugs a Developer Should Fix. I want to show you some mockups and discuss a little bit about the idea. I created these mockups using the FindBugs IntelliJ plugin, and yeah, it's also shows a little bit that I tend to find general approaches to improve the usability, but they are applicable to, should be applicable to virtually any static analysis. That's what I hope. On the left-hand side, you see what's typical, a list, or here a hierarchical list of errors or findings of the analysis. Then in an IDE tool, which is really nice already, having the connection to the source code and also some further information. I want to focus, as I said, on preparing and improved presentation of the analysis results. And so here are some mockups. The white parts are the things where I want to contribute improvements. So as I said, I want to add recommendations. There can be different parameters like time, difficulty. They could work. That's one thing I will have to find out. If a developer has a high priority on getting analysis results quickly, they might need a just-in-time compiler, or the recommendations could be given by heuristics, or also a machine learning approach might be the way to go. And on the right-hand side, I just depicted that there should also be the way to use and to collect developer feedback. For example, if they deem an error to be a false positive, this could help improving this filtering mechanism to filter out false positives. And also, as the tool should be helping the workflow integration, if a developer says, I don't want to work on an issue, they should be able to suppress it for some time. For the recommendations, two ideas I already have and told you a little bit about, the parameters, the factors. One should be time. So as I said, if a developer, for example, says I have 10 minutes to work on a bug, then the analysis results should be filtered and display analysis results with bugs, warnings that are estimated by the recommender to be, for example, in classes like less than 10 minutes, less than 5 minutes, and now the developer can just choose one of the errors that they deem to be appropriate to fix in the time they have. The other thing could be that developers choose whether they want to work on difficult issues or easy issues. Developers have different levels of experience or preferences on what to work, and so also there should be a way, for example, to have a heuristic estimating the difficulty for an issue, and then again the recommendation for which area a developer should focus on. To develop this tool, this RUInBugs, I depicted here my project plan. Currently, as I said, we're working on the statistical analysis tool survey, and as a next, using the results of this, I intend to perform a survey with developers, interviewing them on their needs, and this is my requirement analysis to find out what developers need and how, come up with concepts what RUInBugs should provide the prototype that I intend to develop. For the development, I want to use the project group that we have in our university, in our master's program. There we have a group of students that work on a project for 1 year. I expect this to be really productive. I did it myself and want to do this in an agile manner, a user-centered development approach, focusing on the concepts that we can implement them and test them. And once the prototype is finished, I plan the evaluation with a user study in the form of a comparative lab study. Does this prototype actually improve the usability? Here are some early research questions that I want to answer in this evaluation. I plan to refine them as well. The first one is, in general, does this do static analysis tools with a specialized user interface for recommendations improve the developer's user experience? Does it really help? And then, if so, to get a deeper understanding, I believe it's interesting to learn which factors are actually contributing. Like, do developers use the estimated time to fix, or is it the difficulty? Which parameters are the most important one to developers? And lastly, do developers, when using this tool, actually trust the filters, the recommendations? Do they accept the tool, and does it help to help them to integrate static analysis tools into their work life? I still wanted to give you some pinpoints for the survey that we're conducting. We are looking at about 125 suggested tools that we gathered from lists from GitHub, highly rated static analysis tools from NIST, from CERN, and others. Those tools range from security relevant tools down to simple linters, so from highly complex analysis to simple ones and everything in between. And also all types of tools, CLI-based to IDE plugins and integrated ones, and also browser tools, or tools where the results are displayed in a browser. So we want to get the big picture of the current state of the art. And we're evaluating those tools against usability features that we found from literature, like the warning messages. Are there explanations? Are they connected to the code? Is there fix support given? And many things there. And this is what I'm doing now in the preparation of the development of the tool. And I want to come to an end with the outlook of the idea that I have once the tool is working and hopefully actually helps. So one future development that I see is when the tool is working. As I said, for the recommendations, there needs to be some heuristic or machine learning approach, so some model on predict or make the recommendations. And so having some model about how the developer works with it, for example, for the difficulty, should be helping to have an understanding of a developer in the inside. And so having an assistant that gives recommendations tailored to the developer using the tool would be a really great and helpful thing, I think. And the assistant could give explanations, for example, in regard of cryptography, errors that the developer oftentimes does, give further explanations how to actually use, and for example, encryption algorithm correctly, and give further hints. And so in the long term, I envision some form of assistant that can also teach or help a developer improve their coding style, their coding skill. Yeah. That's it. Thank you for your attention. And do you have questions?
Thanks, Michael. So now we have some time for questions. We already have one question in the chat, which I may read. So where do you think existing solutions are failing the developers? How far are each of these solutions from your ideal analysis tool? There's, for instance, SonarCube, which seems to include most of the features you mentioned: estimated fixing time, issue clarification, detailed explanation, silencing options, etc. Wouldn't it be easier to integrate with an existing, perhaps commercial, comprehensive solution to experiment with new usability features?
Yeah, that's a good point. SonarCube is a tool that I really enjoyed looking at. As stated here, it has a lot of those features, but the one big issue I see there, for example, is that it is not integrated into the IDE. You have this disjointed process of the analysis, reading the analysis results, and then having to apply them to your code and fix them in your development.
There is a plugin for most editors like VS Code. It's called SonarLint that is included.
Okay, thank you for this input. Yeah, but the other aspect is that there, as it's also stated, SonarCube is a commercial tool, and making access generally to static analysis tools easier is thinking something really well and worthwhile. And SonarCube does not cover all the things that can be analyzed with static tool code analysis. And as I said, for example, with CogniCrypt, that is a tool specialized on cryptography, and being able to integrate or apply my approach idea to any static analysis should help you to integrate the analysis that you need for yourself. And also, when you use a commercial tool, this you rely on the analysis and the development of the tool of the vendor.
It's not entirely true, because most of tools that I know of, like commercial solutions, they have a plugin system. So you could write your plugin system and run whatever analysis tool you want for whatever kind of purpose you want. Yeah. And I'm mentioning this because it seems to me that your project involves a lot of implementation work. Writing user interface is really hard, busy work, not so interesting, difficult to publish. And then you need also to have this, you mentioned that you want to have this kind of field study after to evaluate, which will be very difficult without a robust solution already. Because it will be hard to convince developers to just use something that breaks half the time. So I think it would be simpler to just run with an existing solution, even if it's commercial, and see what you can do from there. You could also contact some company and say that you are working with this awesome new integrated feature, and there might be some possibilities here to leverage the implementation burden that you are putting on yourself.
Yeah, sure. Thank you for the idea. I'll look into that.
Okay, then we have the next question from Alistair.
Thanks, Michael, for the very interesting talk, and thanks for contributing to the doctoral symposium. I like your idea of doing an evaluation with students because I think it's great to do user evaluations, and clearly for the kind of work you're doing, it's essential to have one. I wonder, though, what the drawbacks to using students are. For instance, I guess ideally, well, static analysis tools are probably going to be used in earnest by professional software developers who may have a lot more experience using IDEs or using analysis tools than the students do. So I wonder if you could maybe talk about what the threats to validity might be there.
Yeah, I thank you for a good point. Threat to validity is the result of the developed prototype. Oftentimes, it can happen that the design might be flawed, or there's a lot of rework needed to maintain the code, or use it further. And from my experience, this is something that needs to be addressed in the supervision. So in my case, I was lucky to have good supervisors who took care and always reminded us to have good maintainable and documented code and well-designed code, and rather have maybe have less features, but a good project. And so
my apologies, I think I may have misunderstood something. So sorry, I thought you said that you were going to have students be continuously using the tool.
Oh, no, no, then I'm sorry that I didn't point it out clearly enough. So I wanted to use this project group for the development of the tool.
Okay, that makes sense. So for your user study, who would be the subjects of the user study?
The subjects should be developers. Ideally, developers using static analysis that are already using static analysis tools and are familiar with it, and also, for example, researchers. Researchers that we know that use static analysis tools.
So yeah, okay. In that case, I guess my question is, do you have access to a large pool of such people? How can you make sure the pool is somehow not too, it's not too much like amateur developers, but it's not people who are already kind of converts to static analysis. In some sense, you'd like a kind of serious but unbiased software developer to be your population.
Yes. So in our research group, we have contact to several companies. I plan to contact them, and also so in our research group, similar studies have already been done, and I want to ask my colleagues and on their contacts.
Okay, cool. That's good.
Yeah. All right. Thanks, Alistair. So we have another question from Emma.
Yes, thank you for the talk. And this is a very interesting area. I've worked on the tricoder system for a number of years, and I'm quite familiar with the difficulties there. And I really liked that you mentioned that this focus on users is something that I really sympathize with, that some things are just not useful, even though they're considered to be correct by the compiler people. So I wanted to, you also mentioned that you want to integrate at an earlier stage, and this is definitely something that was done to some extent in the tricoder system, even though it's not mentioned much. There are additional concerns about performance, for instance, when you do that. But other things that when we've studied sort of code review, when you present things in code review, you sort of normatize what's happening within this organization. And in a setting where we try to do things in the editing case instead of in code review and specialize towards a certain user's needs, there's a risk that these things diverge. So I was wondering if you've thought about that case, and if you see what I mean, and then if you have some ideas about sort of how you could tackle that sort of potential challenge.
I'm trying now to understand it correctly. So with tricoder, tricoder is normative to what the the company needs, or with the code review what they think they need, but there might be developers or parts of teams that have different needs than what is normatively given by Google in this case. Yeah, I haven't thought about it too much at the moment. Part of it is because in my current focus, I assume a smaller target group, not that much scale, that highly scaled as in Google, and the analysis should be executed in the IDE. Otherwise, the IDE integration wouldn't really work, and so for now, it's more like focused on a singular developer or a small group of the developers, and in this case, you should still be able to adapt the analysis or the interface to the needs of the smaller group.
Yeah, I mean, I guess the issue becomes the bigger one when you have more people that need to agree together. So I just wanted to sort of highlight that this is a property that you then get when you start to move from a project configuration to a user configuration. There's some food for thought, perhaps.
Yeah. Thank you very much.
Okay, thanks, Emma. Then we have another question from Yvonne.
Just a quick one. Thank you so much. I really, at 5 o'clock in the morning, I thought, oh my goodness, this is going to be hard. It was a great talk. I really enjoyed it. I love the name of the tool. I also did understand or misunderstand. I thought that you would be using students, but it did make me think, and I understand now that you're not, but it did make me think, oh my goodness, this is really interesting. So when you have all these different developers, and in particular people that are learning, when you have this, hey, this will take you about 10 minutes type feature. I mean, I'm just curious if you could talk a little bit more about that feature and how, it would be so different for different people and how that might work. But I think it's really exciting work. Thank you very much.
Yeah, thank you. First of all, to all who thought that it was a study with students, this is an idea that I just picked up, but it would be amazing for, I said that I hope to get to something like an assistant that teaches. I just thought about it would be a great idea to have the study with students then, if they feel that it helps them to use such a tool. And then going back to your question, the actual way how this recommendation should work or this model should work is something that I'm at the moment struggling with. I think I will go several steps. So in the first approach, just make a simple heuristic. I don't know if you can read it here in this in the slide that I still have open, but you see there. I think one of the errors was dead store. Is kind of like dead code. If you have classes like this, first step could be just labeling them that dead code typically takes just a few minutes, because you should at least check if there's a reason that it's still there or remove it, but others could be more difficult. So for the analysis that I built the tool on, having just a first kind of preset model and then try to develop a more sophisticated heuristic, or using, for example, that could be some way call graph information or other things that the analysis uses with a machine learning approach. However, if I would go into this direction, then the general applicability of this tool wouldn't be there anymore. This is something that I will have to find out.
Okay, thanks, Yvonne. There's one silent question from Christos. So could you please say more about the mechanics of the recommendation, and in particular, how recommendation takes into account the specifics of different analyses? That's also a good one.
I think I just already addressed this a little bit. I'm not sure about this for the different analyses completely yet, and yeah, this is one of the things that I will have to address in the implementation. And for how I intend that this should work is, yeah, having for the different parameters like time, difficulty, or maybe also type of errors, yeah, a model that decides or classifies like the estimations of how much time would be spent, and then having a filtering system to present the findings. And also, when I now mention type, this is many static analysis, as far as I've seen, also in our tool study, have at least some form of category of or some code connected to the finding. For like, if it is a linter, there's oftentimes rules. So a first step could at least be for the static the findings that you, yeah, preset a certain amount of time or difficulty level for the finding types. And one way then would be to that the developer that integrates their static analysis into RUInBugs would have to yeah, also give some information about the error types to configure the recommendation model. Also, this is again something where I thought if I would use this approach, machine learning could be interesting. So if the developer integrates
Michael, I unfortunately have to stop you.
Okay.
Otherwise we would
Sorry.
run out of schedule. No problem. Thanks for your answers. I would say we can take the remaining questions offline. I mean, there's a breakout room, which is called Doctoral Symposium in the Crowder platform. We can then just continue in the break, which is from, yeah, in my time zone, at least 16 till 17:20. Please check out your own time zone, because this is new, like virtual conferences where we have multiple people participating from multiple time zones. So thanks again. And I would
yeah,
now...
only one thing. I unfortunately forgot to register. I'm sorry for that. So I don't have access to the Crowder room. Yeah.
Okay, so then maybe people stick around in the Zoom room here for the coffee break.
Yeah, if you that would be nice, or
Thanks.
just send me something. Yeah, thank you.
I would then hand over to Arnab.
Yeah.
Okay, so you can see my screen, right? Okay, so I'll start. So hello, everyone. My name is Arnab Sharma, and I'm from Paderborn University. And today I'm going to talk about a property-based testing framework designed for the machine learning programs. So first, I'll tell you a bit about how machine learning works. Probably all of you already are familiarized with how it works. So your machine learning works in two phases. First is the training phase and then the prediction phase. So in the training phase, machine learning algorithm gets trained on the training data. And this training data, you can take it from some open data repository, like you say ML or KGL, or maybe from some historical data. And then the machine learning algorithm can be chosen from some libraries like scikit-learn or TensorFlow. So at the end of the training phase, what we get is a predictive model to which if some prediction input is given, it gives you an output class. These days, this machine learning model is being used as a decision-making software in many application domains, starting from social, economical, transportation, law, medicine, and many other domains. Now, depending on the domain of the application, there are certain properties which need to be guaranteed for a machine learning model, such as fairness, monotonicity, security, and robustness, and there exists some also others. So over the years, researchers have tried to address this problem of validating machine learning model with respect to some important properties like fairness or privacy or robustness, and they have either focused on a particular kind of properties, or they have taken a particular type of machine learning model. Let's say, for example, a deep neural network, which is really have a nice performance, and people are really using this these days. But there is a gap in here. So so think about it, that you have to use a machine learning model for a particular purpose, and then you see that you need to validate 3-4 different kinds of properties. And for that, you have 3-4 different kinds of techniques. So you can use your use 3-4 different techniques to validate your machine learning model. But you, of course, you have to learn to use this different validating mechanism. And also, it might happen that some of this validating mechanism is accepting only a particular type of machine learning model. It does not work for all types of machine learning model. So that's the idea of property-based testing. So what if the user can specify the property by using some kind of specification language, and there will be a kind of validation mechanism which can automatically check this on any machine learning model. So the machine learning model here doesn't matter. So it can be a completely black box. So this is where I thought of using building a property-based testing framework where the property can be specified by using some language, and there will be an underlying testing mechanism which takes as an input the machine learning model and validates it. So the idea is to specify the property by using some kind of common standard specification language. Let's say, for example, assume method constant. So many people are familiarized with this kind of specification. And I've already used, or I've already developed this verification-based testing mechanism, which can be used then to automatically generate a test case trying to violate the property that has been specified by the user. And of course, this is a testing mechanism. Hence, if verification-based testing is failed to find a test case violating the property, that does not say that the machine learning model guarantees the property that is specified. So our goal in this work is to develop a testing framework which can be used to test any given machine learning models. So in this work, the approach consists of mainly 2 parts. So first part is to specify the property, which can be done using, as I said before, using some using assume method form. And then the verification-based testing, which automatically will try to generate a test case violating the property that has been specified by using this assume method form. So first, I'll tell you a bit about how this property specification using assume method can work. So I try to take an example to make you understand that. And for that, I need to introduce some formalism. So, so machine learning model can be defined kind of a function which takes as an input a feature vector and give you an output class or output prediction. I'll take an example as the property monotonicity, which is basically saying that if some input feature values are increasing, then the output prediction should also be constantly increasing. Now this can be formalized by saying that, okay, if x and x prime here, if they are two feature vectors, and then if we are computing the monotonicity with respect to feature I, then if the feature ith feature value for x prime is increasing and all the other feature values are fixed, then the prediction of the x prime should also be increasing. Now, this can be easily specified by using this assume method form, because this gives you a kind of pre-post condition format, and then this feature vector can be defined by using a kind of a array. And then we put in the assertion at the end that the prediction of the x should be more than the prediction of the y. So I'll explain you in the upcoming slides that how it can all work out. So how this property specification can be used to generate a test case violating this property. So this way, the property monotonicity can be specified by using this assume assert form. So after the property is specified by using this assume assert format, next step is to use the testing mechanism to test the model for this property that has been specified. So verification-based testing, the testing mechanism that I've developed is consisting of mainly 4 parts. So first is white box model generation, then the computing the property on it, and then the variation, and then white box model improvement. First, I'll tell you briefly about the first steps, white box model generation. So as I've said before, that the machine learning model that has been given to us is a completely black box. So I do not know anything about it. So what I want to do is to apply some known analysis technique on the model, but that is not possible if I use a completely black box model. So that's the idea of using a white box model from it. So how it is being done. So basically what we do is generate a fixed number of data instances, so feature vectors randomly. And for each of these data instances, get the prediction from the black box model. So what we have is a set of labeled data instances, and which can be thought of as a kind of a training data, and we call it as an oracle data. And then we use these oracle data to train a decision tree algorithm. And then at the end of the process, we get a decision tree model. So what we're saying here that the decision tree model is an approximation of the black box model that has been given to us for test. And of course, this approximation process is not 100% complete, but somehow we try to fill up this gap by using subsequent steps. But the idea is to be able to apply some kind of analysis technique on the decision tree model to find the test case violating the property for which we are checking the black box model. Okay, so after generating the white box model as a decision tree, I also will take an example to explain how this computation of the property works on the decision tree. So this is a very simple decision tree with two features, contract and income. So you can think of as a leaf nodes as a predicted class, so 0, 1, and 2 as a predicted class. And these are the constraints. So if contract is less than 11, then the predicted class should be 0. So first, what I do is I convert this decision tree to logical formula. So this can be easily visualized because you can think of it as a kind of a constraint. So if the contract is less than 11, then it implies that class 1 equals to 0 and so on. So each of the branch of the decision tree is converted to a corresponding form. And I'll take the same monotonicity example to explain the whole step. So I am considering here in this example also that I'm computing the monotonicity with respect to a feature. So in this case, the feature income. So what the next step would be to convert this specification to the logical formula. So what I do here is take the assumption and then using some kind of specific, some kind of grammar, so some kind of context-free grammar to convert this assumption to logical formula, and also convert the assertion and then add the negation of the assertion to the logical formula. So after doing this, we conjunct all these three formulas. So the logical form of the decision tree, the logical form of the assumption, and the negation of the assertion formula, and then give it to the assembly solver, which is in this case the Z-tree. And what Z-tree will do, we'll try to find a satisfying example for this formula. So if we can find a satisfying example with the negation of the property, that means that the property is violated here. So might happen that Z-tree cannot find anything. So it cannot find a satisfying example. So it says an unsat, and then we stop there. So although it might happen that the black box model has some violation of the property. Of course, this is a testing mechanism, as I've also mentioned before. But if I can find a satisfying example, so for the monotonicity case, I'll find a basically pair of satisfying examples. Then I check it that whether it really is a contract, or whether it really is a test case conforming to the black box model or is in a black box model for test. So what I do is check the validity of the test case, and if I find it valid, then the job is done. I found a contract example or I found a test case violating the monotonicity property or the property that has been specified here. I'll quickly skip to the last step of our verification-based testing mechanism, but I'll revert back to the third step. But first, need to understand that why we need the third step. I have to describe the last step. So the last step is the improving the white box model. As I've said before, that the approximation procedure, so converting from the black box model to decision tree model is not a 100% approximation procedure. And it might happen that the test case that has been given by Z-tree is a completely invalid one. So what I do is I take the original prediction from the black box model for this test case and then retrain the decision tree again. But the problem is, if you think about it, so retraining just by adding this only single counterexample or only single test case is really ineffective or inefficient, in the sense that the training is really a costly operation, and retraining just by adding a single counterexample would be really inefficient. So that's where I needed the third step, which I call as the variation step. So what the idea is not just generating a single test case in one cycle, but generating a number of test cases. And this is done by using two mechanisms, feature pruning and branch pruning. So the idea is these two pruning techniques use the SMT solver Z tree to generate a number of test cases from the single test cases. And yeah, at the end of this one cycle, we'll have not just a single one, but a number of counterexamples, which can be then used in the subsequent step. So if we can find a valid counterexample amongst them, then our job is done. Otherwise, we go on. So I will not discuss in detail of the pruning strategy, but if you would like to know about it in more detail, please have a look at our paper, which were pruning algorithms. Both of the algorithms have been detailedly described. So to summarize our verification-based testing approach, we first generate a decision tree model from the black box model under test, and I compute the property on the decision tree model by using the SMT solver. And then I try to generate a number of test cases by using pruning techniques. And if I find a valid counterexample amongst them, I stop. Otherwise, I continue. So far, I have already implemented this idea of verification-based testing to test the monotonicity of machine learning models, and it has been found to be quite successful and beating all the existing techniques. And I've also developed this idea of specifying the property for testing the fairness properties of the machine learning models. And yeah, so both of these works have been already published, and they're openly available, publicly available for people to use these tools. Yeah, and for fairness cases also, I have compared it to a number of benchmarks and found to be quite effective compared to the existing approaches. As a part of the feature work, what I plan to do is to check other different types of property of the machine learning models, not just fairness and monotonicity, also other types, and also incorporate a secondary white box model. What I mean by that, I'll explain a bit, and then make the approach applicable for other types of classification problems, and at the end, a verification approach, combining a verification approach for the tree-based models. So checking different types of properties. So this can be easily done. Of course, we have a kind of limitations that, of course, I cannot check the properties that cannot be specified by using this assume method construct. So as long as the property can be specified by using this specification language, I can check for that for any kind of model. And this can be easily done. So I plan to use it and compare with the existing testing approaches for those other types of properties. Next thing is to use another white box model. So far I have told you about this decision tree model approximating the black box model that has been given to us for testing. But what if the decision tree completely fails to approximate the black box model that has been given to us? It might happen because decision tree can be completely bad to do that. So that's where I thought of using a different white box model. So because of the performance and also because deep neural network found to be really effective in many domains, I thought of maybe use a deep neural network as a kind of secondary model. So what is the idea is basically the user can specify, or it can be automatically plugged in if it cannot find a counterexample decision tree by going to the deep neural network. And then rest of the framework remains the same because it can be done, of course, only if, of course, if I can convert the deep neural network model to also logical formula. So this is, of course, a challenge, but thanks to some research that have already been done in this area, there are works where people have tried to convert the deep neural network model to logical formula. So some of the works have tried to address this issue and then try to come up with techniques where they convert a given deep neural network model to a set CNF form. So of course, this can be done. And of course, deep neural network can be integrated into our framework. Other types of classification problems. So far, these properties that I have told you about, this fairness or monotonicity or robustness, they mainly and they mainly are associated with the single level classification problem. So what it means is like for single level classification problem, you have a feature vector, and for that you have only a single prediction, like only a single prediction for it. But for there is a kind of classification problem which is called multi-level classification. So there, instead of having a single class, you will have a set of classes. And there are some interesting properties that are there in the multi-level classifications. And I am planning to basically extend this approach for validating these other types of interesting properties with the help of the approach. So these three things I have done already and sent it to a conference. So it is under submissions. And yeah, so I'll now try to summarize what I have told you. So I've told you about a property-based testing approach and an underlying testing mechanism, which I call is a verification-based testing. And then as a part of the future plan, I plan to extend it for other types of classification and regression problems. And also probably this is also another idea too, because I can easily convert this decision tree to logical formula and then basically verify the property on it. So the tree-based models like random forest or decision tree or created or any kind of tree-based model can also be verified by using these techniques. So then I plan to implement the kind of approach where the user can give an option for verification and the tool can automatically check it. So thank you for your attention. I'd be really happy to have your feedbacks and if you have any questions. Thanks.
Thanks, Arnab. Any question to Arnab's talk? Then maybe let me start with the first question. You said that you already have implemented some of your parts. Have you already evaluated that implementation? And I'm not an expert in neural networks, but like what would be the real world requirements, and how does your implementation perform in order to meet those requirements? Could you comment on that?
Yeah, I actually have implemented the part of this using the deep neural network, but yeah, of course, there's a problem. Like if you use an SMT solver, like converting to logical formula, so this approach is also not really scalable to very large neural network models. So when I implemented this, I often had the problem of facing scalability issues. So taking a long time when given a complex property, or taking a long time when I fix the network size to be really big. So yeah, this is one drawback that I'm having right now and trying to deal with, that how I can better or somehow can encode the deep neural network in some way that can deal with this problem. So yeah, scalability issue is really a big concern for me at this moment.
Mm-hmm. Okay, thanks. Then Alistair, please go ahead.
Yeah, thank you for the talk. I noticed that you specifically use Z3 as your solver. I wonder whether you're exploiting any features of Z3 that only it offers, or whether there might be other SMT solvers you could use, and if so, whether you think whether you think that there could be kind of performance advantages to using a portfolio solving approach.
Thanks for the question. Yeah, actually, that was also one of my ideas. So maybe using a combination of SMT solver, for example, MatSet, or for example, CVC. So I have found out that for some floating point, if you have a lot of floating point operation, maybe CPC can perform well, but I'm not sure. But yeah, that's also definitely is an interesting things to explore. That if I use apart from Z3 some other kind of SMT solver, how it's going to perform. And by the way, I've also used MathSet to some extent, and it didn't give us a really lot of improvements over the Z3. But yeah, definitely I plan to use some other kind of SMT solver in this to do this.
Cool, thank you.
Thanks.
All right, then we have another question from Doug.
Hi, nice talk. I should have read more before asking this, but I'm going to ask it anyway. If you have features that involve numbers, then all your decision trees are going to be some x's greater than a threshold. In which case, it seems like what you have is a macro level of backpropagation, right? Where you are feeding into one neural network something that is going to be resolved as a decision tree that is going to vary a threshold slowly but surely as you move through the space. Am I completely wrong about that?
No, yeah, this is of course a possibility, and that's why I immediately went for this second white box model, which is using a deep neural network. So it might happen that you have this kind of threshold, and then you run into this problem, and the decision tree is really bad in approximating a complex neural network model, and that cannot give us anything, and might be even worse than a random testing mechanism. It might also happen.
Yeah.
So for that case, I have thought of using this deep neural network, and seems to be somehow solving this problem of having this. If I use a deep neural network as an test case, so somehow can solve this problem to some extent.
Well, the first idea that strikes me is, take inspiration from the folks who use 4-bit numbers and just treat them as predicates in SAT solvers, and then you go 0, 1, 2, 3, infinity, and that might be good for a lot of cases.
Yeah, that's definitely an interesting idea. I'll definitely look more at that one.
Okay, any more questions? That does not seem to be the case.
If nobody has one, maybe I have a kind of clarification or follow-up. So you mentioned in terms of evaluation, you evaluated it on some benchmark models. So what were those? How did you identify those? Is there somehow a community set of benchmark models for this kind of thing, or what was that?
Yeah, exactly. So for the fairness, or for many works, so machine learning testing or machine learning validation, verification, so people are doing it really a lot. So there is a really standard benchmarks existing in the community. So the benchmark data sets, benchmark models. I have used those as an evaluation for my evaluation. I have used just standard benchmarks that are existing in the community already.
Okay. Anything else?
Maybe
Can I ask a question? Sorry.
No.
Yeah.
Go ahead. Go ahead.
Yeah. Can I ask a detailed question about how the properties are encoded? I saw the formula phi m, phi a, and not phi p. So can you explain a bit what phi m and phi a's are?
Okay, so so phi, sorry for the confusion, but actually what I meant is like phi m is the logical formula or logical form of the decision trees, and then we add the assumption, right? So that's the phi a. So we conjunct phi m with phi a, and then at the end we have the negation of the assertion. So basically assertion is saying that if so, as you have to assume, like assuming this disease should be these are my assumptions, and assertion you are saying that the model should hold this. And now at the assertion, when we add this assertion, we add the negation of the assertion, because we want to check whether if we add the negation of the property, then it can be satisfied by the SMT solver. I mean, then it will mean that if it okay, so if the SMT solver can find a satisfying example, then it will mean that the assertion is violated. The assertion does not hold. Yes, that's the idea basically, to add the negation of the assertion. So phi m is a logical form of the decision tree, and phi a is a logical form of the assertion, and phi p is a logical form of the assertion. So conjunct all these and then give it to the SMT solver for solving. So
Thank you.
So
yeah, I'm just wondering if I'm missing anything. So you're setting certain assertions about the decision trees. And are there any other formulas apart from those assertions?
No, I mean, these are the three main parts. So so first is so for example, for the decision tree, the logical form, or the logical form of the decision tree, and then the logical form of the property that has been specified, assumption and assertion. So there are no other logical form that has been added.
Got it. Thanks.
Thank you.
Just a quick one. Thank you very much. I really enjoyed your talk. And this is a little maybe out there, but I'm curious about the properties that you've selected and why you've selected them, and if it's fairly, I mean, it seems like a very extensible model or framework that you have here. I think it's very exciting. And I was in a workshop yesterday about, ethical AI. And so I was like, wow, there's a lot you could do. There's a huge community that's anxious for you to take on some very, very heavy properties. Could you talk a little bit about the properties that you selected and what you're thinking there, or if there's just a well-defined set that I don't know about?
That's definitely interesting. So basically, the properties that I have chosen here. So for example, fairness, as you have mentioned, this ethical part, or the ethical part of the software engineering, or there is a really, in every software engineering community, they are really concerned about the ethical part of the decision-making software. So when the software starts making decisions, it should not somehow harm the society or any community. So for that, fairness is really, really important. And for the others, for example, the robustness, which is really a kind of, so this is kind of saying in a way the accuracy of the model. So how my machine learning model is good or how bad is it? And even the security property, they are also important in some domains, because of course, if the machine learning model is being used as, for example, is spam filter and so on. So if the security is really, the security concerns with that, then it can be really bad performance, and everything can be hacked really easily. So the properties that actually I have chosen, or I have tried to work with, are somehow already also people have worked a lot on it, and yes, somehow also have effect on the communities and the societies and so on.
Thank you.
Thanks for the question.
All right. Any more questions or comments? No, that's not the case. So then we can stick around here in that Zoom room, or we can also switch over to the breakout room in the CrowdR platform. So just do whatever you want. And then you can also follow up with questions to the presenters we had already, Arnab and Michael. So other than that, I would say see you back with our program in approximately 40 minutes.
Thanks.
All right.
Philip, wait a second. Just so that the YouTube streaming doesn't break down, you are not allowed to leave this room. So if there is no more host, then the YouTube stream stops.
I see. Then I'll stick around. All right.
Mind if I test my screen share again? I had to switch places, so.
Go for it.
Sure, go ahead.
Okay, thank you.
Okay, we're getting very close to starting. Welcome back, everyone. I hope you had a good, I don't know, breakfast or dinner or lunch or coffee. I don't know. I got a coffee myself. So we are about to start. I'm just trying to get a hold of Jens Pausberg, who should join us too. Okay. Mm-hmm. I guess we'll start already. Otherwise, I don't know. I don't have an online connection to him, and he's not responding to my chat, but I assume he's showing up any minute now. Good. So we'll get to our second session. Eduardo Geraldo will start, and we'll talk about gradual value-dependent information flow control. Eduardo, share your screen, please, and go ahead.
Okay. May I?
Yes.
Okay. Okay. So I'm here to present the topic of my PhD thesis, which is gradual value-dependent information flow control. Information confidentiality is an essential property of today's systems. Failure to ensure this property can result in significant damage to companies, both financially and to their reputation, not to mention the user's trust in them, and as well as users' trust. When present, information leaks usually arise from hard to detect programming mistakes or faulty logic. Large-scale, thoroughly tested systems like GitHub, Twitter, Facebook, and Instagram show how cumbersome it is to ensure information confidentiality. In the last couple of years, all these systems had information leaks of the same type. All of them leak clear text user passwords to internal system logs. To prevent similar situation, we aim to develop a tool capable of detecting information leaks in large-scale web applications, given a set of specifications or some key points of the systems. In a traditional web application, for instance, one using the model view controller patterns, the specification, those key points would be, for instance, the API and the data layer. where information enters and leaves the system. To achieve this, we use information flow control. As you probably know, information flow control has quite a record in the literature, and it was first introduced in 1976 by Dorothy Denning. It consists in the assignment of security labels to data and data receptacles, that is, entities that can hold information, for instance, register, variables, and even channels through which we can send information. The security labels, in turn, follow a partial order, and together with the list upper bound operator, define a security lattice. Given the lattice, the information flow control, the principle is to propagate the security labels throughout the computations, taking into account both explicit and implicit flows. That is, explicit flows are the ones that arise from a direct assignment, for instance, where we are assigning either X or Y to the register R, and implicit assignments result from the control flow, the structure of the control flow graph. Here, if we have access if we can read the value of R, then we can take some elections regarding the value of V. If R equals X, then V greater than 42. And if R equals Y, otherwise, V lesser or equal to 42. Given okay, so after propagating the security labels throughout the computations, we have to prohibit illegal flows, that is, flows that go against our policies. For instance, here for the specification of the function threshold if, we've specified that it returns a low integer, an integer with the security label low. However, here in the return, we are returning the value 37 with the security label high. Therefore, we have an information leak, and we cannot proceed as it compromises data. From Denning's model, others came forth. For instance, one of such models is the dependent information flow types by Luisa Lorenzo, which consists in the parameterization of security labels with runtime values. This is quite advantageous, as it allows for flexible dynamic lattices, which can expand, grow to accommodate new security compartments. Grow at runtime, I mean. Parameterized security labels also allow for finer-grained security policies. Instead of, we can create, for instance, in a system where we have multiple users, which can enter and leave the system dynamically, we can create a compartment for each user dynamically, instead of squashing all users into the same security compartment as other less flexible models do. Okay. Information flow control can be information flow policies can be enforced both statically and dynamically, each having its advantages and disadvantages. For instance, static information flow control, as a static analysis, only needs to execute one single pass over the code. It has access to the program itself, so it can cover all the passes in the control flow graph in a single run. And since it works since it executes at runtime, at compile time, I mean, sorry, it does not introduce any kind of overhead on the target system's execution. However, as a static approach, it generates some false positives, and to provide good results requires complete specifications. On the other hand, dynamic analysis monitor execution traces, and as a monitor, it introduces some overhead on the system. The problem with analyzing execution traces lies in the fact that we have to analyze multiple traces in order to achieve a good coverage of the control flow graph. On the positive side, dynamic information flow exhibits less false positives and supports lightweight specification. For instance, the kind of specification we want for our approach, where we provide specifications just for the borders of the system. Okay, if looking at this, we can note it is noticeable that these approaches complement each other. So why wouldn't we combine them? That's exactly what hybrid approaches do. And that is also why we, in our approach, make use of hybrid information flow control. Okay, more precisely, we propose an hybrid value-dependent approach to information flow control, targeting low-level intermediate representations. The hybrid, a hybrid approach confers us the advantages aforementioned. Using value-dependent information flow control, our approach enjoys from the advantages of dynamic labels, and targeting a low-level intermediate representation such as Java bytecode, LLVM's intermediate representation or the common intermediate language from C#'s virtual machine. We can support multiple high-level languages. For instance, Java, Scala, Kotlin, Clojure, all of them compile to a single intermediate representation, Java bytecode. We intend our approach to support web applications, and therefore, more concretely, we wanted to support Spring-based backend applications. We already have a prototype, Snitch, which performs fully dynamic information flow control, which is capable of monitoring programs executing on Tomcat with Java servlets. This figure depicts the architecture of our approach, given the program's bytecode, the security lattice and the specification files, which are given through specifications for the program, which are given through specification files or Java annotations. We analyze the program. The analysis starts with a static information flow control / monitor injection, because our static analysis does the rewriting itself, injecting monitored instructions where necessary, only when necessary, and then we proceed to the monitored execution of programs. Our language is relatively small. It only has 6 instructions. It has 2 types of assignments and binary ops. We have unguarded instructions and guarded instructions. Unguarded instructions are those that do not need any verification at runtime, and guarded instructions entail some kind of runtime security check. We've based our language on TAL, typed assembly language. Therefore, our program is composed by multiple basic blocks. That is, code sequences terminating either with a jump or with a conditional jump. Okay, regarding the rewriting system, the system follows a big step semantics where given a psi, a gamma, and a sigma, where psi is a mapping between labels and gammas. Gamma is a structure mapping registers to sets of security labels, and sigma is a static stack. That is, it only is used during the analysis. The stack emulates the nested structure of programs on a structured program, on a structured language actually. The sigma, the stack, allows us to keep track of the program labels, the program counter security label. That is the security label associated with the computation itself. Every time we change scope, for instance, if we do if we execute a conditional jump, in the following scope, we have to take into account the security level of the condition used in the branch. Okay, so the dynamic semantic. The reduction of the monitor. The monitor supervises the program execution and performs the necessary security checks according to the instruction it executes. It has an environment mapping the environment age, mapping code labels, block labels to instruction sequences. It's the heaps. Gamma here, instead of mapping to a register to a set of security labels, it maps a register to a pair of pair value security label. And sigma has the same meaning. It's the stack where we keep track of the of each scope of the computation security level. Okay, so now considering an example, this is the lattice we will use throughout the example. It is a value-dependent lattice. It has the low label over there, which is security dependent, value-dependent. Regarding code, we will consider a low-level representation of the threshold if function. And from there, we will only consider. And from that, we will only consider a single assignment because it allows us to greatly reduce the number of rules we have to consider. Okay, here is the rule for a safe assignment. That is an assignment that it is statically proven that it won't give place to an information leak. Here I would like to highlight the condition: the computation security label, the context security label must be lower than the label of the register we're writing to. And if in this case we do not have to rewrite the instruction, it is safe. It does not require any kind of security verification. One thing I would like to introduce since we've seen the comparison between security labels, is the label comparison itself. The label comparison is quite simple in the case of dynamic analysis, since the comparison between two labels only depends on the security lattice. However, in the static analysis, we consider intervals of sets of labels. Therefore, it is convenient to define the comparison. A set of labels A is lower or equal to a set of labels B if all labels in A are lower than all labels in B. If this does not happen, and there is an intersection between both sets, we cannot provide an answer on which set is greater or lower. Therefore, in that case, the comparison is undefined. When the highlight is covering a little bit of information, whenever if we cannot tell whether the security context, the context security label is greater or lower than the registers, that means they intersect, then we cannot tell if a program is correct or incorrect. We need to instrument to rewrite the assignment to a guarded one, and then proceed to the runtime verification. Okay, so going back to the example, let us consider state one here, where the registers, the register R is associated with the set of labels that includes all labels between low 0 and low top, and the program counters label is the set that only has one element, which is the bottom label. In this case, the register's label is clearly superior, greater than the context security label. Therefore, we can apply the safe assignment rule, and this state is correct. There is no information leak. If, however, we have state 2 here, where the register has the same set, the labels between low 0 and low top, and the context security label, the set of labels associated with the context with the computation is the set that includes all labels in the interval high low t. In this case, just those two labels. In this case here, it is clear that the register security label is lower than the context. Therefore, there is no rule that we can apply. This is not allowed. This is an information leak, and therefore the program is rejected. Okay, finally, let's just consider one final state, state 3, where the register is associated with the set of security labels between low top and low bottom, so all of those ones, and PC is the set with the security labels between low top and high. In this case, we have an interception, so we can apply the rule for potentially unsafe assignments, where the comparison is undefined. In this case, we rewrite the rule and we replace the assignment with the guarded version and proceed with the dynamic analysis. Okay, so let us this is the rule that applies for unsafe assignments, as we can see there. Potentially unsafe assignments, as we can see there by the assignment sign with the dot on top. We have now rewritten the instruction, the assignment instruction to be a potential unsafe assignment. Considering the state we had statically, we know for sure that that all possible execution states at runtime will respect those boundaries. So here we have a runtime state where register is associated, where register R is associated with the value 42 and the label low top, and the label and the program counters label is the security label high. In this case, it is clear that that PC is not lower or equal to the register security label. Therefore, this assignment, this assignment will result in an information leak at runtime. Therefore, once again, we prohibit the execution of this assignment. If, however, we have another state, or the one below, where register R is associated with the value 42 and the label low top, and the PC is the label low top, then the condition verifies and this program is deemed correct. This is one example where a purely static analysis would raise a false positive. Although this assignment is valid, it is correct, a static analysis would reject this program. Okay, so now that we've presented the process that a label goes through, that a program goes through. To the best of our knowledge, there are no approaches that combine both hybrid and value-dependent information flow. There are approaches that use hybrid information flow control, for example, GSL-Ref. There's also approaches using value-dependent information flows. Sorry, there's a mistake here in the slides. It's DIFT that uses value-dependent information flow, not Joanna. I made a mistake in the slide. There's also our prototype, which we've developed, that is purely dynamic and uses value-dependent information flow control. Okay, regarding our work status. We have completed the strictly dynamic analysis. We have a prototype for it, Snitch. We also have the core language for the hybrid analysis and have the non-interference proof for the monitor. We are now working on non-interference for the hybrid monitor, and then we would like to extend our prototype with hybrid analysis capabilities and also support for string. As some evaluation measure, we would like to also develop a framework for test generation directed to information flow control and benchmarking this type of analysis. To conclude, we've presented the hybrid value-dependent approach for information flow control in low levels. An implementation targeting intermediate representations, more concretely Java bytecode, and an orthogonal specification mechanism. We can provide specifications either through the code itself, or if we do not have access to the code, for instance, in a closed source system, we can provide specification files for the system's interfaces. Okay, that's all. Thank you for your time. Any questions?
Thanks a lot, Eduardo. Yeah, I'm giving the word to the panel for questions. Let's start with Christos with a Zoom question.
Okay, so a lot of practical applications require declassification. Have you looked into this kind of policies, and how does this change your system, and especially the guarantees that it provides?
Well, for instance, our current prototype, the fully dynamic one, also already has the classification mechanisms. In the current one, we still have to take that into account in our proof. Yeah.
Okay, that's not a question. I just want to point out something. Also, it will be good to look at Heiko Mantel's work on hybrid information flow control monitors. For, he also has some work for hybrid stuff. Thanks.
Thank you.
Great. Then we have Dave.
Hey, yep, great. Thanks. So great talk. Thank you. It was very interesting. I apologize if I missed this context. I got distracted by something going on in another OOPS room for about 2 minutes, but I was wondering about the context in which this will be used. So it seems like you're doing this dynamic analysis where if there is an information leak, you dynamically basically reject something, right? And that by itself is kind of an information leak. So is this designed to be used during testing, not in production? Is that the context? So you're going to use this to test programs before they're actually deployed, not as a protection mechanism? Okay.
Probably we do not want to publish to push a program into production when they have a monitor which introduces overhead. We want our system to be our best, so it is targeted at test environments. Yeah.
Okay. All right. Good. Thank you. That makes more sense to me then, and it looks interesting.
Okay, I have Yvonne with a Zoom question.
Sorry, thank you very much. I think I said that to you privately by accident, Matthias. But yes, I really enjoyed your talk, Eduardo. And I'm just wondering about, your first slide was showing these very high-profile leaks, and it made me think about the way that you're going to be testing your work and what kind of applications you're looking at. And if I can imagine you circling back and actually taking on one of these high-profile leaks.
Yeah. Okay. I didn't mention that detail about evaluation. What we were thinking, I talked with my advisor about it, is to, once we have Spring support, test, benchmark / test, evaluate our approach using existing Spring applications from industry, for instance.
Great. Thank you.
Okay. Then next up is Doug.
Hi. Good talk. I'm wondering what where the borderline is between dynamic checks that reject and some notion of autocorrect, where you're trapping a situation, you know what should be done by virtue of trapping it. Why don't you just do it if somebody is using your tool and is forced to run it in production without some intervening programming effort, where the programmer is most likely just going to do that anyway.
Sorry, I didn't listen very well. Could you please repeat the question? Sorry.
Okay. I'm wondering what the border is between your tool causing a dynamic rejection versus your tool auto-repairing to give a safe answer in the case of a possible violation.
Actually, I've never thought about it. Okay, we can trace back to where the to where the problem was inserted. Okay, so if we propagate a label, so at some point we will reach an information leak. The security label is we're writing to a register whose security label is lower than the context. We can see what writes occur to that register and try to pinpoint exactly which value, what concrete write gave place to that register, to that register security label. And then at that point, we can maybe offer some kind of proposal to make the program correct. As I mentioned, it's an aspect I've never thought about. Sorry.
Yeah, my main point is that that's precisely what the programmer would be doing. Why not do it for them?
Yeah, it's a thing I'll consider in the future. Yeah.
Sorry to interject, but Jeeves is one system where they're using something similar to what Doug just mentioned, and it might be checking.
Okay, Dibs, I will check it.
Good questions. Anyone else has a question?
Can I ask?
Absolutely.
Okay, I have 3 questions. The first was relationship to taint analysis. So I remember particularly Jonathan Bell's paper from something like OOPSLA 2014, perhaps. That's totally dynamic, of course, and does rely on specifications also. How is that related?
Well, our monitor dynamic information flow control is a taint analysis. We taint information with security labels, and just down the flow we check if it is if it meets certain conditions. I don't know if I'm answering your question.
Oh, so yeah, so it's like that paper to me stood out for executing the dynamic analysis with less overhead than I thought possible. And so my question has to do with whether if you knew that paper, whether you can say something about whether your overhead is equally low.
I do not, unfortunately, I do not know that paper. So far, we've done some tests with our purely dynamic analysis tool on relatively small programs using Tomcat. The overhead I got there was the time elapsed increased in a factor of 1.7, if I'm not mistaken.
Okay.
I was actually expecting to be higher, to be more than the double, but it is actually lower than I expected.
Yeah, yeah. Okay. Second question. How much time does it actually take to execute a dynamic check? And does it differ based on different data types?
The dynamic check is quite fast. I don't see why it. Okay, the dynamic check of a whole program, right? Or just the comparison?
No, a single dynamic check. I'm wondering how much work goes into it.
It is quite fast. It's just a comparison between in the Java, I would say it is what the call of 3 for equals methods. So
yeah, that definitely sounds good. Okay, last question. So you showed various very nice rules with semantics and everything. Maybe I missed it, but do you have also a theoretical side with theorems and stuff to this?
Yeah, I do have. I have it on that's what I've been working on. We've been working on the interference there. We have some theorems regarding non-interference of the approach. I can show it later if you wish.
That's good to hear. So I think so it shows both a theoretical and experimental side to the work. That's very nice. Yeah, many thanks.
Thank you.
Great. Anyone else?
I have a couple of questions if anyone else doesn't have any questions, because So the first thing is usually dynamic information flow gives you different guarantees than static information flow. So for instance, dynamic information flow without multi-execution cannot catch explicit flows because of implicit flows because of code that is not executed.
Yeah.
So how do you account for that in your proof now that you are proving non-interference for the hybrid?
Sorry, okay. That is taken into account in our assignment rules. That's why in our rules we do not allow for we do not allow assignments to registers whose security label is lower than the context security label. If we only write to registers higher than the computation security label, then we do not have to worry about the security label of the branch guard to be leaked. It cannot be leaked as it is only written in. It only influences registers which cannot be seen at that point.
Okay. So basically, this means that the mechanism is flow insensitive, right?
Yeah.
Have you observed whether this has affect the practicality of the approach?
So far, I do not have any observations regarding that, the effect.
My last question has to do with the value-dependent labels that you have.
Mm-hmm.
So what is exactly how are they defined? Is the lattice defined statically with all those value-dependent labels, or are those created dynamically?
Yeah, those are created dynamically. We just have there a security label which has a parameter, for instance, an integer that represents the user ID. When we just have to instantiate a label with that ID for it to be in the lattice. Every label that is parameterized with, for instance, here the example. Every low with every possible number is in the lattice. It is automatically in the lattice. They might or might not be used. Here we usually only include in the lattice the ones that are in use, but they are all in the lattice. The lattice comprises all those labels. I'm okay.
I see. So you have an infinite breadth lattice, basically. That's what's happening.
Yeah, basically. Yeah.
Okay. Okay. Thank you.
Great. So we basically reached the end of the time period, but we have like 5 minutes break. So if somebody else wants to ask a question, that's fine. Otherwise, we'll take a 5-minute break. You can quickly go and grab a coffee and be back for the next talk in 5 minutes. Okay, let's do that. See you in 5 minutes. And thanks a lot, Eduardo.
Thank you.
So Raphael, if you want, you can already probably share your screen.
All right.
Great, I can see it.
Fine.
I'm sorry, just one quick question for Christos. I didn't quite catch the name of the author. Could you please send me or repeat the name, please?
About which one? Heiko's paper?
The one in Uppsala.
Oh, I think Jens mentioned that. I think it was Jonathan Bell's paper from a few years back.
Thank you. Okay,
Yeah.
I've taken note. Thank you.
Perfect. So time for the next talk. And this one is going to be by Raphael Mosaner on machine learning to ease understanding of data-driven compiler optimization. Raphael, the stage is yours.
All right. So hello, everybody. My name is Raphael. I'm a PhD student at Johannes Kepler University in Linz, Austria. And I'm glad to give you a little insight into my work as a PhD, which, as already mentioned, is about machine learning in the context of compiler optimizations, but with a focus on keeping things understandable and not replacing everything by machine learning black boxes, but rather helping the compiler engineer doing his or her job. So I will be using the term compiler heuristic quite frequently now. So just let me give you a brief definition. Compiler heuristics are metrics in the compiler to decide which transformation or optimization to apply and in what way. So for example, when taking a look at this code snippet here, which could be present in your compiler as well, there we compare a code size delta, which is weighted with a weighted performance delta. And depending on the outcome, we do a particular transformation or optimization or not. So for example, we could check whether the code size increase wouldn't be too bad when unrolling a loop. And if this is okay, then we would do the transformation. So when taking a look at this, the weights are definitely considered as heuristics, as they are typically defined by humans and set to some value which makes sense to them. And also the whole if condition can be considered as heuristic, as putting the code size delta in context with the performance delta is also some artificial metric created typically by humans. And in state-of-the-art compilers, the workflow for implementing heuristics looks typically like this. So we hopefully have a very smart compiler expert, which comes up with some heuristics which are implemented in a compiler and then evaluated on a let me say reduced set of benchmarks, because it has to be feasible for the compiler experts to analyze the performance of the compiler on the set of benchmarks, and depending on the results, then the heuristics are updated, and this is an iterative process to refine the heuristics, make them better for the benchmark programs, and hopefully also for all the programs out there. So in general, this approach requires a lot of domain expertise by the compiler experts, and it has also the disadvantage that it is only feasible to analyze some few benchmark programs. Therefore, we have to do an abstraction from all the real-world programs to some few benchmark programs, which hopefully contain all the important patterns which are required to trim your compiler for dealing good with programs in the real world as well. Furthermore, the heuristics are most of the time very static or one size fits all, as they are trimmed to the benchmark programs. And manually crafted heuristics also require manual maintenance and updates. This has pros and cons. So on the good side, if they have to be manually updated, then the compiler expert who updates the heuristics hopefully knows what he's doing, and he or she keeps understandability of the whole system high when manually maintaining those heuristics, but it is also error prone to some extent. So this approach is kind of experience driven. And in the last, let's say, decades, machine learning has risen in importance more and more, and also found its way into the domain of compiler optimizations. So I've depicted here a very general way of applying machine learning. So on the one side, we shove in some features in the target. In our context, features could be, for example, number of branches in a function to be compiled, number of branches in a function to be compiled, or number of memory operations, or some graph-based features when you have an intermediate representation of your function. And the target value is the one you want to predict, basically. So this could be the best optimization decision, the best loop unrolling factor for a particular loop, or it could be some estimation of the performance of after compilation, for example. And you shove that information into a machine learning black box, and it spits out some heuristics. Alternatively, some compilers also may use a prediction process during compilation itself. So this process would look like this. We have a compiler compile a lot of different programs, so we are not restricted to some few micro benchmarks, like when manually analyzing those benchmarks by compiler experts. We can use also user-specific programs in case you want to tune your compiler for a particular domain. During compilation, you can extract a lot of features, use them to train a machine learning model, which is then deployed to a compiler and makes decisions during compilation. For example, peel this loop or don't peel this loop, stuff like that. This process is to some extent semi-automated, but it also resembles a bit the waterfall model in software engineering, as when new data arises in traditional approaches with offline learning, we have to redo the whole learning again. So in essence, machine learning in compilers enables us to capture a way larger amount of the real world, as we are not restricted to few benchmark applications. We have an at least semi-automated approach, although having this waterfall pattern in there to some extent. But there are two big disadvantages. The first one is that machine learning often comes in black boxes. So, and when there are multiple black boxes in your compiler, a point may be reached where even the compiler experts do not know anymore what is really going on in their system. So the machine learning black boxes reduce understandability and also maintainability of the whole system. And which is also a big point, it makes it hard to infer further compiler knowledge, because we just have those black boxes telling us how optimization should be applied, for example, but it is hard to gain further insights into the processes in a compiler. And another big disadvantage, which hasn't been much of a deal in past work on this topic, is that online prediction has an overhead. Most research in the past using machine learning in compilers used a static compilation setup. So the compile time is not really a big deal there. But when using a dynamic compiler, as we are doing in our studies, compile time is a very crucial factor, as it directly impacts also the overall execution time of the program. And when you deploy a machine learning model into a compiler, it definitely takes longer doing some prediction than just checking if a certain threshold is not exceeded. But in essence, this approach is very data-driven. So what we propose now is to use machine learning rather assistively in the compiler. So we want to take the best of both worlds, basically. We want to take the maintainability and the iterative refinement of the human-crafted heuristics and the data-driven approach with some automatism in place as it is present in the machine-learned heuristics approach. And we want to combine these good parts from those two approaches and create some hybrid approach from this. So let's take a look how this would in theory then look like. We would still have the orange part here, which is taken from the human crafted compiler heuristic side. So we still want the compiler expert to have full control on the heuristics and on the processes which are going on in the compiler. This should keep understandability high and also makes it easier to maintain the whole system. But rather than having to analyze some few benchmark applications to trim your heuristics to, we want to support this by having a machine learning pipeline here. So this is the blue parts here. So using machine learning, we are very open regarding the programs we want to use. We can compile loads and loads of programs and automatically produce a lot of features which can be used to train different machine learning models for different predictive tasks. And now the difference to existing approaches arises. We don't want to use those machine learning models and do the whole compilation decisions based on such black boxes. So parts in the compiler which are crucial for understandability, for example, deciding whether to apply a particular optimization, let's call it loop peeling, for example, or not, those we don't want to replace by machine learning black boxes. Rather than that, we want to use the models to assist the compiler in some minor tasks which are not crucial for understandability. But the more important part is we want to support the compiler expert to verify or fix the existing heuristics. So to summarize the key points, we don't want to use black boxes in parts which are crucial for understandability in the compiler. We want to have automated feedback based on environmental changes. So the machine learning model can tell the compiler experts then, the input data has changed to some extent. The programs have a different structure, which are compiled now. Your current heuristics do not fit the data anymore. Don't you want to think about updating this or that heuristic? And we want to use this approach for inferring further knowledge for compiler experts. It can be helpful for problem analysis. As already mentioned, your heuristics do not fit for this pattern I have found in some weird user program code. You might have not taken that into account. And this can also compensate some lack in experience. Lesser experienced compiler engineer might not even have thought of such pattern when designing the heuristics, and the machine learning model can then point such things out for him or her. So this is a kind of data guided approach where the compiler expert is still in control of the internals of the compiler to keep understandability high. So this is a bit the abstract depiction of this whole process. We have conducted a case study to show how this can be put in practice. This case study was done in a project together with Oracle Labs in their Graal compiler, which is a highly optimizing dynamic compiler, which is quite on a production level already and running on millions of devices. So it is quite optimized and should contain few to no errors. We took a look at the duplication transformation in the Graal compiler. So in case you're not familiar with this kind of transformation, take a look at this code snippet here. We just have an if-else construct and followed by a return statement. And code duplication does copy code after control flow merges. So we have this split at the beginning of the if and the merge again after the else. And we copy this return statement upwards into the predecessor block. So in both the then and the else branch here. And why would you do this? This, of course, bloats up your code and increases code size, which you do not want usually. But when done smartly, using duplication, we can enable further optimization. So in this case, we could, after duplicating some code, enable some constant folding and get rid of some assignments here, for example. But when done prematurely, duplication, of course, increases the overall code size drastically, which is not good at all. So typically in compiler, which supports such a transformation, there are heuristics to trigger duplication. So this is the same in the Graal compiler. There's a heuristic which compares the estimated code size increase with the estimated performance gain from a potential duplication. And if some thresholds are met, then we perform this duplication. So we were interested in the heuristic for estimating the change of code size, the code size increase or decrease after duplication. And in the Graal compiler, there is a human-crafted heuristic for this process, where for the compiler intermediate representation, which is a graph-based representation, as shown here on the right-hand side, for each node which has an impact on the final machine code size, an abstract cost or size is annotated. So you can see a return is for example, annotated with a 2 and a multiplication node with a 1. And by adding those nodes, node counts, node costs up, we can estimate the impact on the code size change when duplicating a particular part of such a graph. So there is a handcrafted model where over 450 different IR nodes are manually annotated with a code size and an estimation in execution cycles. And this is based a lot on experience, and what we wanted to do, we wanted to verify or fix this existing cost model for estimating the size impact of a duplication. So we wanted to learn the actual code size impact based on a lot of data rather than on human experience. As the features for our machine learning task, we used the IR node count. So for each function to be compiled, we collected the number of add nodes, sub nodes, if nodes. So with this, we also had some structural information at least. And we wanted to predict the code size then of the machine codes in bytes. So here you can see an example of a small snippet of our feature vectors as it looked like. We compiled a lot of functions and extracted those information. So to show the problem with this whole prediction process, here you see an abstract depiction of the compiler. We have a lot of phases which are executed one after the other, and we wanted to predict the impact on the code size of the duplication phase. So we had the features extracted at this point in the compiler. But as already mentioned, after duplication, a lot of other compiler phases tend to be applied. So for example, the constant folding, stuff like that. And therefore, the features, the graph features extracted from here are modified by other phases. So those phases after duplication influence actually the graph at this point here. And therefore, while this problem might have looked like some linear regression-like thingy to be solved, we had to take this into account that due to the subsequent compiler phases, a nonlinear relation from the graph at duplication time to the code size after compilation is established, basically. So this I already mentioned. We tried at first a linear regression model, but as expected, this mispredicted the code size impact a lot due to those phases here. And we required a nonlinear predictor to also take those subsequent phases into account. And we decided to take out the big guns and trained an ANN predictor on some well-known benchmark suits. The results are shown here with a little overview. As you can see, it predicted quite well. We had 3 out of 4 predictions with errors smaller than 10% when compared to the actual code size. And we then implemented a prototype predictor in the Graal compiler based on a newly introduced analysis mode in Graal, which is the part to support the compiler expert in doing his or her work. So this analysis mode in Graal then printed for each duplication decision, which was different when done with the human model versus the machine learned model. The analysis mode printed information regarding these differences and outputted them in a human readable format for the compiler expert. So there was some output created, like the duplication decisions did differ for this function. These nodes should be duplicated or weren't duplicated using this or that model. Those were the code size differences from the human model versus the neural network predictor, stuff like that. And this was shown then to compiler experts with the hope to enable finding and fixing problems in the human crafted heuristic. And indeed, we were able to find some real bugs in the existing duplication implementation of Graal, which was already shipped and in the enterprise version, and also found some misclassifications in the existing node cost model for predicting the size impact, basically. So I have picked some of the more interesting benchmark results here. As you can see, for example, the chat stream benchmark suite 2 benchmarks, container and towers, had in the default implementation of Graal, of its duplication phase, some severe underestimation of the code size impact, which led to doing duplication way more than it should have been applied. And this led then to a severe code size bloat for those 2 benchmarks, for example, 15% in the towers benchmark, which is quite a lot. And as you can see for the blue part here with machine learning, we could reduce those problems basically, or nullify them nearly. And we were also able then to ship a fixed version of the node cost model, where we, for example, fixed misclassifications in some node annotations. For example, I showed the output to a compiler expert who was working on this node cost model, and he said, oh, it makes perfectly sense from that output that we underestimated the actual impact of a return node, for example, and we have to make this value a bit higher. This makes perfectly sense. And they have overlooked some stuff maybe. And after changing and fixing those misclassifications, we were able to reduce for a lot of benchmarks the actual code size overhead. And we were also reported some 1 or 2 weeks ago that for some benchmarks, Oracle internal benchmarks, due to our changes after using machine learning, 17% performance gains were reported. So this was great to hear. And yeah, I just want to summarize that machine learning can be used in compilers very well, I would say, but you have to take care to not use it as panacea for everything. It is really important to keep understandability high, and you should rather use machine learning to support the workflow, to support the compiler expert, to gain further knowledge. We're researchers. We wanna get further knowledge, wanna broaden our horizon, and not just give up everything and let the work be done by black boxes. And with this, I want to conclude my talk, and I'm open for questions now. Thank you.
Thanks a lot, Raphael. So let me start. Ben had the first Zoom question.
Yes, thank you very much, Raphael, for a very interesting talk.
Thank you.
Also, the previous talks were also very interesting. I just wasn't quick enough with my questions. But for Raphael, so you learn from the, so you basically learn from the benchmarks that I understood. And
yes.
So that kind of by construction and by will forces you to be a little bit biased towards these benchmarks.
Yes,
I mean,
definitely.
This is by construction. So I mean, it's great to hear that the internal benchmarks are now running 70% faster. but in the end, we want to make like everyday applications faster. So what did you do to inspect kind of the representativeness of the benchmarks?
So this case study was just aiming to show that this approach can help to find problems in some existing heuristics. As you mentioned, it is definitely biased towards those 5 benchmark suits, but it would be in a production environment. So apart from this constructed case study, we would also, for example, crawl GitHub repositories or extract programs and broaden our database for training our machine learning models. So to have a more general approach on solving those problems and not just be biased to towards some benchmark suit. So this point of criticism is definitely correct, and we will definitely use more data than for the larger studies we plan to conduct.
Great. That was no criticism, by the way. I was just curious about your plans for that.
Yeah.
Thank you very much.
Yeah.
Okay. Next question came from Alastair.
Thank you very much for that really interesting talk, Raphael, and I thought your slides were very good as well. I guess my question is kind of related to Ben's, in that you mentioned in the beginning of the presentation a few times that the programs might change. Like, yeah, I think you used that phrase, the benchmarks might change or the programs might change. And I wondered if you were kind of interested in a domain where the compiler is really a bit domain specific. It is being focused on not the set of benchmarks used to train the machine learning, but perhaps not any programs in the wild. And if I think about a compiler like GCC or Clang, which compile the spec benchmarks and they compile themselves and they compile OpenOffice, I presume, and all kinds of applications, is there any notion of a good set of benchmarks to drive compiler development in general? Or is it better to actually focus on a compiler that's being used in a specific domain?
We are actually, what we are now currently working on is a feature extraction mechanism to broaden the scope of our work and to have actually every world programs be used for training our machine learning algorithms. So I hope this goes in the right direction. To also have then compilers trimmed to particular domains, as you already mentioned, which could be quite useful, I guess. I would say in general, if you're using machine learning and have the opportunity to crawl and use a lot of data, you should also use as much data as possible. And it's true, we use just those 5 benchmark suits for our case study, but in reality, when our project is a bit more mature, we plan definitely to use any kind of software which can be compiled by the compiler to extract features and to update or to make our models better, basically.
So thanks for that. But if I might just follow up briefly, if I don't know too much about machine learning, but I'm wondering if you train on a kind of huge but rather ad hoc data set with all kinds of different programs with not much in common on them, are you likely to find a good one-size-fits-all model, or might you actually just not find a very good model for anyone, like you know, kind of lowest common denominator model? And might it be better to actually say, okay, we do want to train on a large amount of source programs, but we want programs that are in some sense similar because we want to try and make the compiler work really well in their domain?
Mm-hmm. I think as when taking a look into nowadays compilers where we have human crafted heuristics there, they seem to also work somehow for any kind of program. So I guess at least the level of the human crafted heuristics can be achieved also by machine learning. When also, even if you're learning on a very heterogeneous data set, for example, it might not work perfectly for subparts of those programs, but I think the general performance should be at least on the level of the human crafted heuristics, I guess. because
okay,
they're also
understood.
static or trimmed to fit the average use case.
Right, the human ones are themselves one size fits all. Right,
yeah.
Thanks.
Great. Next question is Dave.
Great. Okay, so thanks for the really interesting talk, and I think you're going after an interesting problem area. I've personally been the compiler engineer dealing with machine learning models a bunch of times. That John Cavazos and Michael Boyle had an UFSLO paper in 2006 that then caused me to go off and tweak our heuristics some in the JAGS-RUIN compiler. So one thing that I don't know if you've looked at this or not, but to sort of deal with the sort of effect of all the post phases, at least in the context of inlining, one really important heuristic is looking at what you know statically about parameters to then predict what the benefits of inlining. So I mean, Jeff Dean had a really great paper in LNFP in 1996, actually, looking at this, where you predict the effect of the cost and benefits of inlining by looking at, the second parameter I know is a constant, a compile time constant, and that means that this is attractive. Versus if it's not a compile time constant, I don't care. So have you thought about how to feed that kind of information into the machine learning models to predict the benefits and costs of doing things like duplication or other optimizations?
So basically what we did was to estimate the cost of duplication in terms of code size increase. We could maybe do the same with estimating the performance, although I think this would be a little bit trickier. So we just started this entry task with predicting the code size impact. But as you mentioned, I think this is a perfectly valid point, and we are currently investigating on a more performance-oriented side how we could estimate the outcome of particular optimizations and how we could learn then a model based on this. So we are currently investigating in this direction. Yeah.
Yeah, I mean, I think the example you gave, to be concrete, like the code size of that return statement is very different because one of the things that feeds into it is 2 versus X, right? And so you're able to do a constant fold.
Yeah.
And so you want to feed that into the prediction. Okay.
So there is, I think in our case that the neural network is this more powerful than compared to the human heuristic, because we can take way more information and contextual information into account than rather assigning an abstract size to every kind of return statement, because as you mentioned, depending on the return type and stuff like that, the cost of a return statement might be very different. And the more information we take into account, the more we could, I guess, model this, and I guess this is the reason why, for example, here the machine learning model still outperforms the human crafted model in several cases, and we won't be able to reach that performance with just this linear regression thingy algorithm for the human crafted heuristic, which is fast, although.
Okay, all right, thanks.
Great. So next in line is, I see Jens waving, but I have Emma and Doug first. Emma wins, unless. No.
Okay, thank you. And thank you for the interesting talk. I was wondering a little bit about the heuristics, and so you have this case study you've done, and what the effort that went into that, and then also if you go through what the effort is in one question, but then also how does it affect the compiler if you imagine this approach being successful and you want to go and apply it at many different places in the compiler? Does it affect the maintainability of does it inject things into the compiler and so on?
So the goal of my work is to try to keep understandability as high as possible. So where it makes sense to change heuristics depending on output from machine learning models, where it is also understandable by compiler experts why they should change particular heuristics, the changes should definitely be applied. But we do not want to give into the into it to have machine learning models then take over the problem because they are more accurate or perform better, but we leave understandability behind. So we want to use this approach only in cases where compiler experts then actually change the heuristics, and they can only, or hopefully change the heuristics only if they really know, or it makes sense for them to change them based on some information they have gotten from a machine learning model. So we do not want to use this approach as panacea to replace everything in the compiler, which was carefully set up by compiler experts, because we can get 1 or 2% in performance, for example, but in the future this will bite us then, I guess. So we have to be careful where to apply this successfully to keep understandability high.
So one follow-up quickly, when you're talking about understandability and communicating with the compiler engineers, how is this communication happening at the moment? So are you, because compilers, you can implement them in different ways and so on. So is this kind of like looking at error recommendations from an analyzer? Is that kind of what this looks like, or is it?
In this case study, it would be similar like that. Yes, during a compilation process, for example, there would be generated in our analysis mode an output file where some notes are made for the compiler expert, looking like this, for example, and the compiler expert then is able to pick up the functions which were compiled. Graal has this way of taking a look at the intermediate representation of the compile graph at any time. So it is really convenient to take a look at the nodes which would have been duplicated and one could take a look at the compiler patterns and then see how, or hopefully understand why this pattern wasn't processed in the way the machine learning model would propose that it would be processed, and then help to fix up the problem. So we provided a textual output here for the compiler experts, but this can be varying, I guess, from problem setup to problem setup.
Okay, thank you.
Okay, I have Doug and then Jens. Okay, Doug, go first.
Okay, so there is not a linear relationship between code size and performance across platforms because of instruction cache limitations, the cost of dynamic code sinks, things like that, that you don't take into account here, but strike me as, well, you're doing machine learning, you might as well put the platform and the thresholds that are being used as part of this mix. Have you considered doing things like that?
So what you're proposing is to basically train a machine learning model on deciding whether to do a duplication or not, and the machine learning model then covers all the heuristics from estimating code size, estimating performance, comparing those two metrics, and identifying whether it is suitable to apply duplication or not.
Yeah, that's where this whole line of thought is leading, don't you think?
Yes, definitely, but this would then be harder, definitely, to infer knowledge on concrete compiler internals. When we would introduce such a black box which takes over so many different heuristics and so much compiler logic, basically, then we would end up maybe having the perfect predictor or the perfect decision-making process for duplication, but the compiler experts wouldn't know anymore how to infer knowledge based from this. So we deliberately reduced ourselves to solving a sub-problem with machine learning in order to infer knowledge for compiler experts, and this knowledge in the case was we definitely underestimated the average size of a return node and stuff like that. But it could be the case that when creating a larger model by using more information regarding code size increase, performance change, then we could maybe create a neural network which functions as the perfect duplication decision maker.
Yeah, go for it.
Okay, Jens.
I want to return to one of the criteria you set up about automated feedback about whether the generated heuristics are no longer good for the new programs coming in. how are you doing on evaluating whether your system can do that?
I would think it would be similar to a bug finding tool. By if it reports bugs, then the tool works successfully. So if we are reported with some differences where the current heuristics do not fit anymore, and we're able to discover the reason in the heuristics and fix them so they support the use case, then this would be a success metric for the process, I would guess.
I see. Well, but you set it up as a criteria yourself. So I think it's good to return to at least. It's a very ambitious thing to set up, but
definitely, and
also
we're
a good thing
still
to
at
do.
the
But
beginning
let me
to
ask
some extent.
a second question.
Yeah.
So you dismissed linear regression very quickly at the beginning. I would like to know though, how far is linear regression off from what you eventually decided was your best thing?
So, for example, when taking a look at this depiction where we have the relative error based from the actual code size to the predicted one, we had some, I think, 20% high outlier at a point where we were 100% off for some examples. So a linear regression model really was a catastrophe for a lot of use cases. So we omitted it rather quickly. Initially, we thought this might be a good fit because we have this also linear regression thingy in the Graal compiler.
Yeah.
Where the code size delta is calculated in that way, and we thought we could directly predict the sizes for the individual nodes, but the process was not that easy, and thus we transitioned to a neural network then.
I'd encourage you that's a useful result to tell people that, hey, the simple thing really didn't work.
Yeah.
Yeah. Very interesting.
Okay. So any last questions? We're already past the time, but if there's some last questions, we can still catch them because we are going into another 40-minute break.
You can always reach out to me via email, of course, or ask me in the Zoom chat afterwards or in the breakout room. Just contact me if any questions arise.
Great. Let's do that then. I mean, we can stay in this chat and this in this Zoom room. If you guys want to chat, just stay here, talk to each other. And otherwise, the next session will be 40 minutes from now by Leon on model-driven development of mobile applications. So have a good break, and I'll see you again in 40 minutes.
Yeah, so I had one question for you. So when you're doing the so you want to find out that heuristics are wrong. So I guess you're running a mode where the heuristic says do this thing, and then you just do the opposite. And okay, so you're just in a so
this was the analysis mode, which was quite slow, of course, because we had two things running parallel. But yeah, we enabled this just for finding the problems and yeah.
Okay, it seems like this could pretty quickly blow up. So like one of the things you look at is phase ordering problems. Like I've got a whole bunch of compiler optimizations I want to run it together, and now I've got an exponential number of things to try to override the compiler expert. So how do you think you would tackle that?
I think this would be quite hard. So there's a lot of research targeting the phase ordering problems. So we haven't really thought about a problem of that complexity yet, because we wanted to just start slowly and tackle problems which we can describe more easily and more easily infer knowledge to fix problems in the compiler. The phase ordering problem would be, I think, a completely different scope of applying machine learning, I'd say. Right. So everything I would say now would be premature. So I just would investigate this in the future and maybe come back with you with a paper at some point.
Okay. Good. All right. Thanks.
You're welcome.
Hi, Raphael. I have a quick question if you're still here.
Yeah,
And
of course. Yeah.
I was really, the slide that you had your results on, the Game Boy results. Sorry, this is just a curiosity of mine. Those ones seemed the most extreme, or maybe I'm reading it wrong. I was just curious about maybe a few details on those results.
Okay, I'll just reopen my slides, but I'm afraid that I won't be able to explain those details to you, as I, together with some other guys at Oracle, investigated those benchmarks but just ask your questions and maybe I can.
And it's fine. You do not have to have any specifics, because it's not as though I would be following the details of it anyway. But I'm curious with, just generally with the results that were the most surprising to you and the types of heuristics that were being suggested, if you had any kind of intuition there. Have I got that right? Is it the game?
So the Game Boy one over here?
Yeah, so the have I got this right? So on the throughput side,
yeah.
Is there any kind of categorization or instinct or anything there? They seem outstanding to me.
Yeah, it looks kind of weird. So with the predictor for the code size, we seem to only duplicate cases which could later be optimized to reduce the overall code size. But by focusing on keeping the total code size very low, we also seem to have not developed the full potential of duplication. So thus the throughput isn't as high as when compared, for example, to the default or the fixed version without machine learning. So I added it in here because it had some interestingly looking result, where it can also be seen that sometimes machine learning does stuff that is rather hard to explain. And this also makes my point, as we could use a machine learning model everywhere, but we would then have output which would look to some extent weird, and it's hard to explain why the machine learning model results in stuff like this, where we couldn't develop the full potential on throughput, for example, but reduce code size to a point lower than without duplication enabled at all. So some weird behavior, definitely.
Yeah, really interesting.
Yeah.
Thank you very much. Really enjoyed your work.
Thank you.
Beautiful presentation too. It's going to be an absolutely great thesis. Congratulations.
Thanks a lot.
Sure. Bye for now.
Hey, whoever's in charge of things, can I do a quick check that my slides show up?
Yeah, sure.
Okay.
I see them.
Okay, great.
Okay.
We can see
Good.
it. Yeah.
Thanks.
You're welcome. Leon, are you already here?
Yeah, I'm here.
Would you like to also share your screen and try if it works?
Of course, of course.
Cool.
Is it appeared?
Yeah, cool.
Okay.
Okay, great. I think we can start now. Hi, everyone. I'm Nafisa. Welcome back to the third session of Doctoral Symposium. I hope you have enjoyed it so far. The first talk of this session is going to be with Lian Al-Wakil. She's going to talk about model-driven development of mobile applications. Please, Lian, go ahead.
Hello, everyone. Thank you for your introduction. My name is Leanne, and I will present to you our research that focuses on model-driven development. My talk will be in 4 parts. In the first part, I'm going to talk about the motivation and research questions. Then the second part includes research methodology and the problem, followed by a presentation of our envisioned solution. And finally, I'll go on to talk about future work and conclusion. Now let's turn on to our first part of my talk. There are 3 reasons that motivate us to select mobile application. The first reason is the development of Android and iOS are complex and time-consuming, since they are required specialized programming mechanism and libraries of each platform, and due to the evolution and diversity on each platform. The second reason is the repetition of similar functionality and built-in technology and user interface design pattern for each new app. And this problem are conflicting with reusability principles. Finally, my consideration should be considered due to the limited resources of mobile devices, such as screen size, processing power, battery, and connectivity to ensure the effectiveness of the developed app. So we suggest to use model-driven development as approach for developing a mobile application. And model-driven development is software engineering approach that can synthesize mobile application from high-level specification to automatically generate implementation in different platforms such as iOS and Android. This approach have many benefits such as fast development, because each element in the model represents multiple lines of code. Also, it can increase the quality of the application because the application is generated automatically by engine that was written before by expertise. Also, model-driven development can be cost-effective due to the possibility of the development with short time to market and at lower cost. For example, it can be done with less people, efforts, and time, as well as it will facilitate reuse because we'll generate both mobile application from single model. Our focus will be on health domain, which considered as a critical domain because it's deal with sensitive and big data. This means that data should be secured and require analysis to give useful information. However, these factors increase the complexity of the implementation. Therefore, a reliable framework is required to ensure the quality of the developed app. The main research question that this research aims to answer is it possible to generate high-quality, complex, and intelligent cross-platform mobile health application using the model-driven development paradigm? And if so, how? To answer this question, we follow a constructive research approach that depends on artifact as a proof of concept. Thus, the research aims to develop a framework for modeling mobile health application, which can be accomplished through three main phases. The first phase that we started our research is critical review of current approach of developing mobile apps. Then we have conducted a systematic literature review to get empirical evidence of characteristics and the challenges of mobile health application. Then we follow an incremental iterative approach for developing the framework, starting from developing the meta model and Android code generator. Then in the third part, we will testing and evaluating the practicability of the generated framework. From the related work, we find an empirical investigation of performance overhead in cross-platform mobile application that had conducted by Pyro and Hansen. They compared the CPU usage of mobile devices, memory consumption, and time completion of invocation on 5 different approaches. And they found that the native approach has the best result, followed by model-driven development. Based on their recommendation, they recommend practitioners and industries decision makers to look more toward the model-driven approach. Here, the schedule that they presented in by Pyro and Hansen, and as we see that the native have the top level of this approach, followed by model-driven development. However, the other approach, like Hyper, have the lowest weight in this framework. Also, we have compared our proposed framework by other framework that use model-driven development. As we can see, there is MD2 and MD2 and BIMAR. As we see with regard the specification of MD2 and our framework, they are textual. However, the BIMAR is a textual and graphical. to design the mobile application in MDT and PyMar, it's require a manual modeling, while our framework support manual coding with inference engine, with the help of course, with AI, artificial intelligence. MDT has a predefined CRUD, which means create, read, update, and delete functionality components. And also in PyMar, and also it supports some graphical user interface. However, our framework is more complex and support machine learning. The architecture of our framework have different design patterns, such as MVC, Viper, MVVM, and Enterprise Information System. The other approaches has just have MVC for the front ends. All approach support fixed code generator. However, we support also a full OCL, which means object constraint language. In the domain, both approach support business app, data-centered business app, as well as augmented reality in PyMar. However, we focus on health apps. And in case of a platform, they support all the frameworks support Android and iOS. However, we have a Kotlin and Swift rather than Java and Objective-C. Also, we have conducted a systematic literature review, as we say, to get empirical evidence of characteristics and challenges of existing mobile health apps. The systematic literature, our systematic literature review have 3 main phases. In the first phase, we reviewed 44 studies about mobile health application from 7 different digital libraries, including IEEE, Science Direct, SAM, and so on. In phase 2, we have compared 21 applications that exist both in iOS and Android app stores, and we analyze them to find some problem and also get some characteristic of them. Then in phase 3, we have analyzed 26 open source code of health mobile application that exist in GitHub. From this critical review, we identify the following problem: the lack of supporting artificial intelligence in model-driven approach. The existing methods do not generate complex and intelligent application. They only, as we said before, generate CRUD functionality, which contain of create, root, write, update, and delete. And also they do not support machine learning libraries and external services such as the cloud, which require manual coding from the developer. Also, we found the absence of customized functionality, architectural design pattern, and security aspect. By comparing our proposed framework with the existing framework, we can find here in the existing framework, there is only 3 main tiers: presentation, business, and data source tier. While in our framework, we have 5 tiers. In the first tiers, we have a client user interface tier to represent different screens. Then we have the presentation tier for navigation controller, view controller, and backing pins. Then in the third tier, we have a model facade and value object that will encapsulate the details from other tiers. In integration tier, there is a data object, data access object, and service activator. And in the final tier, the resource tiers, we have a database, media player, and remote services. Now, let's move on to our evaluation. Our envisioned solution, sorry. Here is the figure that represent our proposed framework that consists of components and the specification and design of mobile health application with knowledge-based system. The component include encapsulating the frequent machine learning algorithms such as K-nearest-neighbors algorithm, SVM, naive Bayes, and so on, decision tree. And also we use a design heuristics regarding the user interface to restrict the number of use cases where no more than 3 use cases can be managed in one screen. Also, we have other heuristics such as we have a limited number of input field on each screen, disregarding the limited size of mobile screen of mobile device. To evaluate our framework, we will specify and generate several complex case studies related to fitness and self-healthcare management, with measuring of development effort, size of application, size of app specifications, and generated app code, as well as the effort that some student consuming during the development of mobile application using our framework, as well as manual coding of the same application. In addition, we will use a sonar cube to check the technical depth and code reliability, as well as PMD to look for potential problem like suboptimal code, overcomplicated expression, and so on. And finally, we are planning to measure the performance of apps based on range of various devices. So to sum up, we have presented our research to model-driven development of mobile application. The main challenge lies in designing model-driven development framework that generate complex mobile application with the quality of manual one. The proposed solution is developing a framework for component and the specification design of health applications with supporting of inference engine. And thank you. This is
Thank you, Leon, for the great talk. Let's see what our panel think about the work. Who would like to start?
Hello, do you hear me?
Yeah.
Yeah, okay. Thank you.
Okay, maybe I can start myself. Great talk. Just one general question. Was there a specific reason that you chose entity approach for this work?
Yeah, our focus is model-driven development regarding to its benefit, because it's cost-effective and we can generate the mobile application in short time. As we know, in our current situation, like for example, COVID-19, we need some application as soon as possible. So we think that when we use a model-driven development will help us support this aims.
Okay, thank you.
I have a quick question. I'm curious about, I mean, what a great application area, you know, when you said, well, COVID, yes, health applications specifically. Yeah. You know, I can think of so many challenges there with the privacy of data and other things. I mean, I think you mentioned that it's big data that you're looking at. I'm curious about, you know, the sensitivity of your approach, or if you could help me understand it for, you know, this specific class of applications in healthcare. It sort of seems to me that I'm surprised, because I would anticipate that you know, model-driven development would be something that would be very amenable to so many different classes of applications. It seems very specific to me. Is there a reason why you're so specific with the healthcare applications besides the fact that it's the most topical thing you could possibly be doing right now?
Yeah, when I start my research, we think about to make our language general, but when we think that if we want to cover the security and security issues, we think about to be more specific to add like security level and the privacy level. So we focus on health application, but maybe if everything go on, we can generalize our language to be more general. Yeah, but at the first time we'll start with only the health and very specific topic. Then maybe we can generalize it. And as you know, this is a PhD, so we have a timeline. So we think maybe when we have more time, we can generalize the language.
I have a quick question. Alistair from Imperial and Google. Thanks very much for the talk. This really isn't my area of expertise. However, I have been involved in quite a lot of projects where a language has been designed for a kind of particular application domain with the hope of maybe generalizing it later. And I've often found that actually the language becomes kind of too specific to generalize, or the generalization ends up being rather unnatural because we've already committed somewhat to the application domain that drove us, and it's difficult to get away from those commitments. Do you have any thoughts about that with respect to your work?
I think at the we are focused now on health application because and it will be very specific. But the main idea and the main things that we follow it, we can generalize it later if everything comes successful. However, no, of course, it will be with different language, not the same, because now it's the language will be specific only for mobile health. But if we follow the same structure and the same methodology, we can generalize it and prove that model-driven development can be successful for other domains.
Okay, makes sense. Thanks.
Welcome.
I had a question just after this question. I was wondering whether it's in some cases maybe it's better to have a custom application for a certain domain if there are certain concerns that you can more sort of address with more precision. Do you have any thoughts on that? And I mean, if you would get stuck in the health domain, maybe it wouldn't be the worst.
Yeah.
That was my comment. But I was also wondering about so you're trying to explore this approach, model-driven development, with the sort of the idea that this hypothesis that this is going to make it easier to develop these apps. And you were talking about developing the same thing using some other approach, and then using, if I understood it correctly, then using model-driven development and comparing kind of the effort. Could you talk a little bit more about how you're planning to set that up? Will the same people be doing the same work, or kind of what's your thinking in setting this up?
Yeah, I have an agreement with my supervisor that because he has a lecture for student for mobile application for bachelor degree student, so it will be like a project of this course. We will we are thinking to dividing the student into two sections, some into two parts. Some parts will manual programming the same application, and some of them will use our framework. Then we will measure the performance and the effort and so on, these things.
Okay, can I ask one follow-up and about what their starting point will be, and then so if they're not using your new approach, what are they doing?
They will develop the same application manually, like any application with the specific requirement. So we will define determine some requirements of our application, of simple application. Of course, it will not be very specific because they are only a bachelor degree student. Then we will measure how many times or how long they use it for developing the lines of code, the effort, how many times they take it to complete the application. We compare both our framework and the manual one. Is it clear for you, or do you have something?
Yeah, I could ask more about this, but I wanted to let other people jump in.
Thank you.
I wanted to ask briefly about how you test and debug these kinds of applications. If you've, for me, one sometimes detractor to using a framework. I mean, the attractive thing about using a framework is you don't have to do a whole lot of lower level work, but there can be the problem that then when things go wrong, things get stuck, you don't have your standard toolkit to go and step through things and debug things, or you may end up stepping through a whole lot of generated framework code. I wonder if you have any thoughts about that.
Do you mean the problem that will appear from the students, or generally on anyone who will use our framework?
I mean, anyone who would use the framework, if you built, say, some healthcare app and you'd generated, the code for Android and the code for iOS, and it doesn't work on iOS, and now you're wondering, is it because of a bug in the way you wrote the app that only manifests on iOS? Is it because of a defect in the implementation of the framework for iOS?
As I understand, I'm not sure if I understand clearly your question, but when someone writes the modeling, they will write only high level. All the low level will be generated from our framework. So we will try as soon as we'll try as possible to generate high quality app without any bugs, or with a little bugs as possible. Yeah, that's the means. So they will only write modeling, and this modeling will not have bugs, because all of them, every code will be generated from the.
That makes sense. But so I guess my question is, suppose you program in Java.
Yeah.
You write all your code in Java,
Mm-hmm.
but then the Java compiler generates lower level code.
Yes.
And it should do so correctly. But if you make a mistake in your Java program, you'd like to be able to step through the execution of your program at the Java level. You don't want to step through it at the level of Java bytecode, or worse still, at the level of machine code. Mm-hmm. So in the model-driven world, I guess ideally there would be some way of stepping through your running application, but stepping through it at the level of abstraction of the model. I'm wondering whether you provide that, or even if you don't, is that the kind of thing that a production implementation would aim to provide?
Really, your question is not very clear for me, but as I understand, when you write a model and this code is generated, you do not need to go to Java unless if this modeling do not support what you want to write. So if you have some specific details that you want to fill in, you can go to Java and complete it manually, because it will run on that, and you can add some code. But we will try as possible to generate everything, and you will not need to go there to low level layer.
Okay, I think I confuse things by talking about the low level layer. I really mean if I make a mistake in my model.
Yeah.
But if it's not apparent to me that I have made a mistake or what the mistake is,
but
is there some way I can debug my model?
Because you will write using an editor, and this editor have some correction and feedback for you. So if there is something happen, for example, in syntax, or it will appear for you. But however, if you write something in the logic that is written, no, still we do not look for it. But maybe I can take it into my account, and so how can I solve it?
Okay, cool. Thank you.
Welcome.
Hi, can I ask almost the same question? Yeah, so this is mostly a logistics question. You know, Android Studio is really pretty good, and people have a fair amount of success making things work even if they don't know what they're doing, and that makes it difficult for you to show with less mature tools that that you're doing something better. How do you cope with that?
I know that Android sites that have a great acceptance from many developers. I know that, but when you're looking for a time that you will take a complete application with short time, maybe it's preferable by many people, and also it will generate both Android and iOS at the same time. So maybe it will be preferable for some.
Yeah, I'm really asking a thesis question of given that you're comparing something with immature tooling to the current state of affairs with more mature tooling, how do you make a convincing demonstration that what you propose is actually better?
By the evaluation of the generated application, if we can compare it with, as we said, by student who develop a manual programming by Android Studio or a Swift code, then we compare the generated application from us. We can also use the automatic tool that I said it in my presentation, like Sonar Cube. We can measure the technical depth, number lines of code, and so on, these tools.
And now I'm really going to ask Alistair's question in disguise. I often tell my students, hey, remember that 10% of everything you do in life is wrong. And this is something that any developer, any scientist should take to heart. That means that people are going to make mistakes at the model level that are unlike the kinds of mistakes they make at programming layers. Have you looked into what kind of mistakes people make?
Because our editor will support some feedback of what the student or people or developer who write, maybe it will learn him. But our view in model view layer is like when we say before we start by 0 and 1 to programming and very low level layer. Then we move on to high level description like Java and so on. And now we try to have an upper layer that it's for model driven development. And we hope to facilitate and make the programming easy to use. This is our vision.
Okay, I'm gonna one last version of this to try to be helpful. I think it'd be really interesting if you could log the kinds of mistakes people made with your tool and try to characterize them.
To give him some feedback in every model that he
to give yourself some feedback.
Yeah. I agree with you. I think if we have a to let me understand carefully, do you mean that if our editor give a developer or modeler some feedback and give him and know if they have some mistake or that, or what?
I'm saying if you just log the errors, which sometimes you'll have to interview the users to figure out what things they did wrong, because sometimes the model level will be, oh, I didn't think by saying this it meant that. So it's the errors of that sort. And if you find out what kinds they are, that gives you the basis of some further follow-ups and evaluation.
Yeah, I agree with you. Maybe I will. Thank you for your comment.
Is there any other opinion or question for Leon?
I can ask a continuation of what I asked about before, if there's no other
Sure,
question.
sure.
So when you're talking about evaluation with students, do you see any risks in setting up that evaluation with those participants?
Still, I haven't, to be honest, I haven't exactly determined which what do you call it? I haven't determined everything that I want to look for a student, but maybe we will determine specific student or a group of student, but the risk, I don't think it is something difficult, because we will give him a workshop to understand our framework, and then they will let them to start and see how they will accept the model-driven development, or they have some question, and I can help them if they have any question. So I don't think it will be a risky. Yeah.
Okay, I guess what I'm thinking of is representative sort of participants for, if you have the option to, at a stage where you've maybe iterated with more accessible participants, which I assume the students are, that you maybe, if you have an industry connection or so, that you could get hold of some professionals and see how they reason about this, and they may have other concerns.
Do you think? Do you mean that we take a professional and a student, both of them, or?
Oh, I'm thinking that you learn maybe different things also, because they're junior developers if they're at bachelor's level. While if you have an engineer with some years of experience, they may see things a little bit differently. So you may get different results.
Yeah, I also we thinking about if we take some master students, so they should have more experience than the bachelor degree student, and also we are thinking to ask some representative, but still I'm not sure about that, because our I have only a limited time, but maybe it will be a great work, I think.
Yeah, that was my.
Thank you.
I guess I had a remark, which is maybe a follow-on to something Doug said. And Leanne, this isn't particularly related to your presentation, but the point that sometimes when you do academic research, you are obliged, because it's the right thing to do a comparison with tools that have been developed by very large teams in industry. And often it can be the case that you've done a piece of research that has some new innovation in it. And if you compare your tool you implemented as a PhD student over 1 year with its special innovation to some other tool that's been developed by a team of people over a long time, it's almost certain that the kind of cumulative effect of all the things they did will overpower your little innovation. And if you, on the other hand, strip back what that team did and turn off all its optimizations to level the playing field, you can be very harshly criticized when you send your paper off for review because you're not comparing against the real thing. And so anyway, I think that if any of you have had that kind of problem in your PhD, then it's a very normal one to have as an academic researcher. And I'm not quite sure what the right thing to do about it is.
Do you mean I do not have to compare my research with industrial one? Do you mean that?
No, I actually mean you do, and it can thus be very hard. So maybe the only advice I can offer is when you write a paper, I think it's perfectly reasonable to just point out very clearly that the industrial thing you're comparing with has been developed by many people for a long period of time, to try to put the reviewers in a mindset that's going to be sympathetic towards the fact that you are not. a massive organization or a company. So I think it's, you know,
Yeah.
I think some people, when they review work, kind of understand this and try to give an academic approach the benefit of the doubt while looking for the scientific novelty, of course. But I think it doesn't hurt to perhaps make the case that you are the, you know, you are the, what's the right analogy? You're the underdog here.
Thank you.
And thanks, Sally, for doing the perfect warm-up for my talk.
Ah, okay, cool.
Okay, then great. Thanks, everyone. I think this was it from our authors this year. I would like to thank every one of them again for submitting a doctoral symposium. I hope you have enjoyed the whole journey, and I hope you could benefit from the feedbacks of our academic panel and audience. For the remaining of the doctoral symposium, I'm very excited to announce that we are going to have 3 amazing talks from our academic panel. We are gonna start with Doug Lee. We are about 2 minutes ahead of our schedule, so I would propose to have a very short break here and get ready for the great talk and come back at 18:14 for the talk of Doug. Okay, our next speaker is Doug Lee. Probably many of you already know Doug. There is no need for introduction, but Doug is a professor at SUNY Oswego. He is a primary developer of several widely used packages, and he's the author of great books such as Concurrent Programming in Java and Object-Oriented Software Developing. Today, he's gonna talk about business design and engineering trade-offs. I'm so excited about it. Doug, please go ahead.
Hi, thanks. So this is a talk on this really oriented towards viewers, audience that's a little bit less far along than the people who have been presenting all morning, but maybe they can see what decisions they've made through it. A little bit of background. I often am in the mode of thinking about engineering trade-offs in all sorts of ways, including about PhD theses, in part because I'm at an institution without a PhD program, which makes me the easiest mark in the world for being an external committee member. I have been on almost 30 of them over the past 20-something years. And so it's a little bit easier for me to stand back and see these things when I'm a little bit of an outsider. So I'm going to start with something that is just an observation that was made in a really good but completely obsolete software engineering text by David Lamb, who started off the first paragraph of the book saying that what you're doing when you're engineering is trading off quality, productivity, and innovation. Doing things well, doing things quickly, doing things at all that had never been done. And that turns out to be about as good a guide to engineering and developing a thesis as a hunk of software. You can translate those sort of obviously. The quality is really the analytic side, what the depth of understanding of a concept. The productivity part is building and building something that you can in turn into programmatic research programs. Creating a basis and then running with it with a series of publications, a series of software releases, and so on. Or the exploratory part where you say, hey, I have this weird, crazy little bit of an idea that I don't think has been done before. Let's flesh it out. And there's some of each and every thesis. So there's a tension about writing, investigating literally everything there is to know about something, and or creating a staircase that you can keep climbing and using the thesis as a stepstone for later work. And the notion that, probably something in your thesis ought to be new, and probably it's the discovery of a new problem rather than the immediate discovery of a new solution. So that's the theme, and I'm just going to walk through parts of it. This is a one idea talk. You have the idea. I'm just going to flesh it out. So if you're focusing on analytics, which is a common thing to do in PL circles, your goal is to say literally everything there is to say about a topic. And some of these are among the most valuable theses ever. Truly terrific works of those that come to mind that are just all over the map because they occur all over. Last year, someone, Heidi Howard, did everything you could ever want to know about Paxos in a thesis, just like the best source to find out anything about consensus, the Paxos consensus algorithm ever. Several of Steve Blackburn's students have done everything you wanted to ever know about zeroing memory in a garbage collector. Completely great, because nobody else would put all that in one place in print, but you can do it in a thesis. So the challenges are find something that has a lot of stuff to analyze, but hasn't been done before, and meaning it's sort of near the edge of what people have done. And finding those edges is sometimes just realizing, oh, we've been doing this forever and nobody actually understands it. And there's quite a lot of that in PL systems. It's by definition narrow. If you're going to say everything there is to know about X cannot be, world peace or preserving democracy or other critical things these days. And the main goal is to inform the reader, saying, well, we now know some positive and negative properties. And the negative properties are among the things you can do in a thesis that you cannot get away with in real life very often. Theses are a great place to put negative results, a great place to put, I tried this, it didn't work, here's a little postmortem. I often say that theses and poster papers are the best places to look for like ideas that you might have that didn't go anywhere, because they don't make it in most publications. And that's really too bad, because it's really informative to say, oh, I have this little idea, I'm going to push it through, and you find out later, well, yeah, someone else tried it and it didn't work for them either. So record your mistakes is sort of an important part of it. Everything I said, it goes across, whether you're a formalist, whether you are an algorithmist, whether you are dealing with things empirically, whether you are doing empirical software engineering. Each of those, so empirical analysis, if you're doing memory management, is the only game in town. There's not a lot of formalisms there, but deeply understanding time-space trade-offs in garbage collectors, really worthwhile. The contextual part of engineering, especially as it deals with processes, and especially as the way people develop software is rapidly changing, if nothing else, because everything is remote. So these sort of contextual things are worth deeply understanding. Sorry. Jeez. It's one of my landlines. All right, so the next trade-off is, okay, you want to maybe trade off how deeply do I understand with something with how can I take steps so that I don't just do this thesis, I do stuff after my thesis. The slogan is your PhD thesis is never your best work, it's just your first work. And so bearing that in mind leads you into the let's build a story. And this is very common advice. It's the advice of, well, do enough to publish a workshop paper, put a poster, and then aim for another conference paper, and so on, and build yourself up through a PhD program. And this means a really different kind of focus than the purely analytic, I want to tell you everything all at once kind of thesis. And it's by far the most common path. I have a lot of sympathy to the what's a PhD thesis? Well, you just staple together 4 publications and you say that's my thesis. If they're heading in a direction that you're pretty sure you want to go in, then that's great. The main issues are if you're like a normal person, initially you're working really close with your advisor, and then you find out that you're not your advisor, and you actually don't have exactly the same interest, and you evolve into something further. And your advisor really ought to encourage that, because it's just good for you and good for them. The downside is, well, if you're going to do this and you're working on anything that's sort of an empirical study, that means you invest in some startup. You put together a framework, a platform where you can keep evolving it. Again, concurrency and memory management are really good examples where people build small frameworks and then they build upon them and they write papers about the interesting things they found along the way. The tough part here is the overinvestment problem, which we actually touched on in the last talk. Is you need to make as much infrastructure as you need to show actual empirical comparisons and things like that. but you do not want to spend the rest of your life replicating, to pick on Leanne, and Android Studio. This is a hard call. Note that I'm not giving you any solutions here. All I am doing is enumerating trade-offs. And the final part is, well, there's got to be something new because that's just how this game works. And the main point of this slide, and what I'm going to say next is, the most successful of these are discovering new problems rather than new solutions per se. Finding a problem that people don't know even exists is a surefire good recipe. In part because other people don't know the problem exists, they're not working on the solution. So you have a little bit of runway before the field comes crashing down on you, because once a problem becomes overly exposed, people run to it. So we see this over and over again in the OOPSLA, PLDI, ECOOP community, where nobody's working on X, and then a year later, everyone's working on X, and you go from 0 papers published on the topic to, you know, literally 3 or 4 people working on exactly the same issue all at once is a pretty common thing to happen. As a frequent paper reviewer, I see this all the time. The best place to come up with problems is finding problems in existing work. The tough part here is that most of the easy flaws were easy to see. So there are many theses who have a misunderstanding of the actual problems in some existing solution that don't get too far because they weren't really identifying the actual flaw. They were finding something that was a consequence or symptom of it. Often the way to say to build a solution is a language, a component, an algorithm. In other words, componentize this idea. The idea is an idea in some abstract sense, but by phrasing it as, well, here's a special DSL for X, or here's a type system that, you know, that captures a new form of delegation, or here's a component that if you had it, you could marry reactive and synchronous communication styles, whatever. So the idea is, if you can componentize an idea, then you can move across past it into developing an actual thesis. Across all of these, comparison is the name of the game. Right? If you have a thesis, you need to be able to compare what you're doing to something else. And you know, often it's empirical, and often that means that real life intercedes, and that you might find that there's a huge variance. You have to narrow down exactly what your claims are. The biggest sin is insularity. You compare something to variations of itself, and nobody likes to see those. You know, my least favorite thing to say about a paper with empirical results is, well, this is all great. You showed the 40 variations of the same idea, but you didn't compare it to anything else existing in the world. So I have no idea what the baseline is. Happens all the time. Don't do that. similarly, let other people make those comparisons. So this is a line, a bullet that need not apply anymore, because when I first, this is a variation of a talk I've done before. When I first did it, there weren't any things like artifact evaluation committees. Yeah, just do it. And finally, you know, some things just don't work out. Make a plan. And maybe your plan is, oh, I'm finally going to watch Jan Vitek's keynote from Monday, Splash 2020, where Jan talks about entire research projects that built up and crashed down, and how he still got the Senior ECOOP Award. All right, that's the talk. I'm really happy to take questions and comments and things. I'll pull this down.
Thank you very much, Doug, for the wonderful talk. Are there any questions? Okay, I have a very general question regarding the planning for writing a thesis, because I count myself still as a junior PhD student, and for me, writing a thesis is something which is really far away for now. I don't know, is it something that you really need to think about the storyline and everything from the beginning, and you need to build up everything from sections to sections, and from like you need to have a very concrete storyline from the beginning to the end, from the first? Or is it just something that you do stuff, and at the end then you make a storyline based on them and then you write them down? Could you please elaborate on this?
Yeah, I think people ought to have really flexible milestones about things, because you're almost surely wrong where you're heading if you're writing a thesis and you haven't, you know, it's like when you're developing a big chunk of software for the first time, all your schedules are wrong, all your metrics are wrong, and you know it's good to have milestones, but the milestones ought to have a meta level of let's do a sanity check here. Is this still where I'm heading? So could whoever is the person in charge cause me to unpresent? It seems not to want to do it for me.
Let me see whether I can. I think currently I am host. I didn't know. I need to figure out how I can do that.
Yeah, it's just not listening to me when I try to not present. I wonder what happens if I clobber.
Let me say stop sharing on you. I don't know what happens. I hope you will still be here.
Yes, yes.
Magic.
Okay, good, thank you.
Great, thanks. Are there any other questions?
Can I ask a question?
Sure.
Yeah, sure.
Yeah, thank you for your talk, Doug. I'm very curious about your point about over-investing of infrastructure. So can you elaborate a bit on this? Like any examples, and is there any sort of threshold for when to stop, or at least you believe it is good to stop at some point?
Yeah. Long ago, I was on a committee with someone who invented the notion of Java obfuscators and used it as the basis of their thesis. But of course, they got commercialized in the midst of it. And so the student basically left without finishing, which was a terrible thing. And through a lot of help and work, we eventually got him back on track to finish it. And the sad thing was, to finish the thesis part was a bunch of analysis on properties of obfuscation and making sure that they were semantic preserving. And he found in the thesis that it wasn't in one case. And so, if he had only finished it, he would have known better. Yeah, so this is where developing some infrastructure to work on your thesis. It was a good story, he's a happy person, but it's a bad story in that it was sort of a little bit of a failure as a thesis. And had it not been commercially viable, then it would have been a bad story all around.
Thank you very much.
Any other questions? Okay, then. Oh, sure.
I was asked Doug a slightly sarcastic question. Where were you in 1996? When I was 3 years into my thesis. That was a great talk. Thanks a lot. And I think it's really good advice to people to think about how to engineer those three trade-offs. I hadn't seen that said so crisply before, because you do make lots of these trade-offs of what you're doing, and you're never going to be perfect. You need to finish. So it was a really nice talk. So thank you.
Yeah. I think the main moral is really it's engineering. You're making trade-offs. Stop pretending you're a scientist if you're in computer science, right? You're an engineer. Ooh, no one on the panel is going to be able to hit me from this far away.
Yeah. Oh, there's a question. There's a silent question from Julia in the chat. So she says, sometimes completely new problems are hard to get published when there's not much related work. Could you comment on that?
Yeah. I truly think, I guess I didn't say this, I truly think that if you do what you love, you always succeed. And I'm hopelessly idealistic about this, but I just see it as true in innumerable ways. That and in fact, Jan's keynote Monday reminded me of this. He's like all these stories about failures of things, but really, Jan did what he loved and got away with it. Anyone can do what they love and get away with it. So if you're doing something really worthwhile, it'll work out. I don't know how. It's like my Pollyanna self.
Okay, then thank you again, Doug, and thanks everyone for being here for the third session. I think that was it for this session. We are gonna be back in 55 minutes, I think, for Ben's talk. See you all in 55 minutes.
Hello, everyone. Welcome back. My name is Chengsong Tan, and I'll be chairing this session. So let's welcome Ben to give his talk about self-marketing as a researcher.
Thank you, Chengsong. Yeah, so the next rough hour is going to be a little bit of fun. And after all of this hard work you did today, you're entitled to a little bit of fun. The reason I'm saying this also is because what follows now is not research. This is totally just only my view that I present you right now. It's not based on any evidence. So it's totally not what you should do as a researcher. But maybe what you should do as a human being, and I'm trying to give you a little bit of insight of what I do there. So also bear in mind, this is just my observations. So you might make totally different observations, and I'm happy to discuss this. So this is 100% my view, and N is 1, and yeah. So you were warned. So self-marketing as a researcher, and the first thing that I ask you is, whoops, and the slides don't work. Now we go. There we go. Is why should you care? Why should you care for doing your own self-marketing as a researcher? And the short answer is you shouldn't. Of course not. I mean, you are indeed, and what we've seen today is exactly what I've written you. You are brilliant researchers. You're doing brilliant research, and people will notice. And people, and these are the people you care about anyway, and not the others. Isn't that the case? So, in the world of science, we seem to think, and this is mostly true from my perspective, is that your thoughts should matter. And that the ideas you work on and the things you investigate and the questions you validate and things you might even prove, that these things are very important and these should be noticed. And I totally agree with that. And this is what we call research. And you publish about this. And in an ideal world, this would be enough for you to receive the recognition you deserve as such a brilliant researcher. And to be invited to more prestigious positions and to do more research and continue on your work. Reality check, is it so? Do you sit at home? Yeah, currently you do. But do you sit at home and ponder about your research and think, someone will notice the great thing I'm doing here right now? Currently you don't have like any option, or do you? So is this the way we should conduct ourselves when going out there? And I think not quite. I think doing brilliant research is the prerequisite. Of course, you need to do this to start actually participating in the community. So you need to do brilliant research. Yeah, that's not the question. But I think visibility makes a difference. So getting recognized in your community matters, and the way you do research when you are connected to your community is also different than the way you do research in an isolated fashion, sitting at home, not talking to other people. And I think in this year particularly, this is very important because we have to somewhat isolate ourselves to get rid of this ghastly virus, of course. But that doesn't mean we should stop communicating and stop being visible to other people. And this is why conferences are important, giving talks is important, and we've heard a lot of good talks today. But what is actually visibility as a researcher? How do we become visible? And I found 3 things to be very important here, and I'm going to walk you through all of these 3 things today. And I think the first thing that you should be findable. So your findability matters. So it should be easy for other people to identify you. And the means you take for this findability, for this recognizability of yourself, they can be quite different. You can wear a funny hat to the conference. People will recognize you for that. Is that what you want to be recognized for? Maybe. Maybe also for your research. So in a way, people should be easily identify you with some topic, or with your name should evoke, this is the person working on this. This would be ideal. But the prerequisite for you to be findable in the community is actually to have a website. And I don't know if it's true for, I think it's true for all of the senior people in the Zoom call right now. They probably all do have a website. Do you as a junior researcher have a website? If not, take this home for today, do a website. And there's really no excuse for not having a website. It's really easy. So last year I did an online survey for where the participants were actually researchers. So we had to look them up, and we have to look up their emails to actually write them an email. And we could only do this if they had a website where the email was listed on, or if they did publications, but that's a different story. And another thing you probably should not do is do not just depend on your institution for your website. You probably all got, like, at your university or your research facility, you all will probably have like a profile with your picture and your name, and most of the time your teaching responsibilities and stuff like that. This is important, of course, but the thing is, you are mobile. You will probably change universities once, twice, a couple of times in your career, and that's normal. We all do this, but your website probably shouldn't change. And if you find all of these forgotten websites of researchers, it's pretty interesting. And the other thing is, your university might think that when you not work there anymore, they will take down your website. So don't rely on some old university website that you are not working with anymore, and don't get in this kind of dependency to that. And I used my university website for a long time as my sole website, so I'm speaking from my experience there. Don't do this. And it's really easy. So website generators make this easy for you. There are a couple of website generators for scientific profiles that even take your BibTeX and make it look nice and so on. So there's no reason not to do it. And you really, but be sure to customize it a little bit so you are a little bit distinct from anybody else a little bit, so that you are recognized again. And let me reiterate, there is no excuse for not having a website. Even as a junior researcher, do it. It takes you like half a day if you're really slow, and then you have one, and everybody is able to find you and recognize you. This is the person that spoke at OOPSLA 2020 about this topic. Well, one thing that I also struggle with a little bit is be consistent throughout your online presentation. So we register at like a numerous amount of websites right now. So you probably all have this conf.researcher.org profile from this conference when you gave a talk. You have your website. You might have a LinkedIn profile. If you are in Germany, you probably also have a Crossing account. This is kind of the LinkedIn for Germany, only for Germans for some reason. And you probably have other social media profiles. And these should all, like, in my opinion, conform to one picture of yourself, one online presentation. And you can decide, do you want to put content in all of these platforms, or do you want to kind of merge everybody into one single channel? But that's up to you. But be consistent. So my second thought about visibility is, of course, you need to attract attention. So you should be making it easier for other people to remember you. Why is this the case? Well, think of the usual attention span of a typical professor. And it might look a little bit like this, and I hope oh yeah, it actually plays. And it might look a little bit like this. So professors, especially if you're senior, you're doing all the things at the same time. You're juggling with 5 balls in the air. Yeah? So make it easy for them to recognize you. If you want to be seen, of course, I mean, if you rotate all the time, it's hard to see a person. But keep this picture in mind when trying to catch the attention of a professor. That's also true for industry, by the way. Because out there, it is an economy of attention. There is a lot of people in the field, and year by year, you can see this in the publication numbers, you can see this in the attendance records every time for conferences. There are more people in the field. And the more people there are in the field, the less likely is it for you to stand out. And so you need to be a little bit forward in catching the attention of someone that you want to really impress. And the thing about that, attracting attention is not very easy. And because it's not very easy, you should take all the chances you have that you get basically for free. Having a conference talk, you don't get for free. You did a lot of research, it's hard work. You did the publication, a bunch of reviewers that, yes, this is very good research. And of course, that's not for free. But once you're there, use it wisely. You got that stage for like 15 to 20 minutes or 30 if you are in the doctoral symposium. So use that really wisely. So whenever you get the chance to do a talk, really get into it and think this is the thing where other people will recognize me. And why is this the case? Because great talks really stand out. People will actually notice if you give a brilliant talk. And people will remember your talk. And especially in this year, where all of these talks are being recorded and put to YouTube, either in a live stream, hello YouTube live streams people, and being accessible years after the conference. So last year we all gave talks at conferences. They weren't recorded. At some conferences, some other conferences did so. And these talks were ephemeral. They were like gone. In the minute you left the stage, you were only in the minds of people. And now you are actually recorded and people can see you again. And great talks there really stand out. This is a little bit of a repetition, but I keep saying this to all of my students, graduate or not. Take all the opportunities to speak, always. Well, let other people speak too, but in general, you know, when you get your opportunity to speak at some place, especially that's not your home, your academic home, do it always, because practice actually makes the professional. The pro tip here, basically, that I learned the hard way over time is you do not need to present every time something completely new. This is also true for this talk, by the way. This talk is based on a talk I gave last year. So not all of these slides are completely new for you. Some of them are, by the way. And this is something really I learned over time. You don't need to redo everything every time if you do a talk. It's actually counterproductive. You can reuse a lot, but be aware that you actually have a changing audience. If you give the same talk every week to the same amount of people, they will notice, of course. One thing that my supervisor told me once is publish wisely. This is one of the many ambiguously defined things. So what does this actually mean? When publishing at your current level, you're typically like in the position to get advices from your supervisor, and supervisors usually know the communities best, so listen there. but always think a little bit also outside the box and think what may extend my visibility. Doug said this in his talk. Also think about workshops. Workshops sometimes are on the lower scale of supervisors saying, should we do this at a workshop? I mean, there's not a lot of attention there and so on. Yeah, but maybe you get the attention from the right people, and the right people that pick up your idea and maybe work on with you on that idea to make it an even greater idea. The ever more popular journal papers that we do in computer science, always go for journal first tracks at conferences. Always give a talk about your journal paper, because otherwise your journal paper, like so many, will be published and probably read by 2 or 3 people, because people don't recognize it yet in computer science yet. So always go for journal first. If you have a published journal paper, that's great. Someone said your research is brilliant, congratulations, but always go for a conference talk afterwards. That's why we have journal first tracks. One thing that Doug also briefly mentioned, always go for artifact evaluation. We have artifact evaluation for 9 years now. Next year we have it for 10 in our community, and this is a great thing. Just so if you haven't noticed this so far, in computer science we noticed that our experiments are reproducible very easily if we give them to other people, and other people can work upon our results if we make that publicly available. And to make this a little bit more visible and a little bit more accessible to people, and to have peer review also for that, artifact evaluation was invented. And this is a very nice quote I found, presumably by Andreas Seller. I couldn't confirm yet, but I think though, and he kind of funnily shares the story of how artifact evaluation came to its name purely by accident. So if you have a better name for artifact evaluation, the community invites you. But just as a brief history lesson here, so artifact evaluation was introduced at ISAC FSE 2011. Of course, people shared research artifacts before, but there wasn't just no formal process before that yet. And the interesting thing about that is it's quite a success story. And here, this is just a bunch of communities that I picked quite randomly. There are lots of more out there, so apologies to anybody that I missed here. So this is roughly the timeline. So software engineering was kind of the first thing to pilot this. Programming language conferences took off, took that very soon afterwards, and it's widely popular. It's spread through programming language in the community much faster than in software engineering. But other people looked it up, like adopted it as well. And this year, interestingly, also the security community adapted it. It's quite a good thing that we're moving to more visibility of our research. What has this to do with your visibility? Well, first of all, you get a nice badge on your paper. And interestingly, these things are now at the ACM conferences are nice and colorful. And they actually have an effect. And in psychology, they did this a little, almost at the same time. Badging they did before us. And here, this black line is the availability of artifacts for research articles in percent. And the black line is the journal that added artifact badging to their journal. So papers are then badged with this. So you might have done it for the badge, if you did it also. Is it boosting your bibliometrics? Good news is it might. There is some preliminary studies on that. We don't know yet. But it might. It might also boost your visibility. Yeah. And if you want to know this is the shameless self-promotion part of the talk. If you want to know a little bit more about that, I actually written a paper about that with 2 brilliant colleagues that was published at FSE. No, this year. I spelled it wrong. It was actually 2020. The only error, but the link is right. So you get the slides and the link is right. And we interviewed all of the artifact reviewers that were out there since 2011. That were over 1,000 people. And they gave us really nice insights about the current state of artifact evaluation. And we did a bunch of things. So if you really want to know what gets your artifact accepted, read that paper. And also have a look at the video, because this was so much work. Doing conference videos, it's so much work. If you have a tool, if you made some good software at some point, do a tutorial. This seriously boosts things. Philip is here also. Philip and I did a tutorial at PLDI 2018 for Phaser, for our static analysis framework. And this boosted usage of that framework so much, we couldn't believe it. That was really, really crazy. So every time you have a thing that other people might find useful, do a tutorial. It doesn't need to be a full day, can be a half day to get people hands-on experience on your tools. This works really well. And usually there aren't enough at conferences, so it's also a pretty easy thing. It's a lot of work, but it really pays out. It gets you totally visible. And one thing that people do, that I do not for everything, but for something, is brand your work. The security people, the security researchers are brilliant at this. They have a name for every exploit they find. They even have a logo for every exploit they find. It's interesting. And people in our community do this too. So there is Felix Pauk, and he has a logo for all of his projects. And they look kind of nice, and you see, okay, he has some kind of color scheme going on, and you get some brand recognition here and so on. Of course, that's work, but people see it. And where do they see it? Basically here. If you looked at the laptop bags of all of your students, you would probably see this, a bunch of stickers. And we did this too. We made a lot of stickers, and sometimes you find money for that. These are not very expensive, by the way, and students really love them. They placard their laptop bags with that, and they are your free billboards for your project. If you get a recognizable logo as this one. We were really surprised how many students actually wanted these, so we actually had to order more. And they also go very well at conferences, I might say. So put them on the conference desk and everybody will pick them up. It's interesting. If you've got more funding, of course you can go for shirts if you're more than one person, if you're like a larger project. Mira did this year. I think that was last year. eCoop, I think, I don't know. Oh, that was Splash, sorry. They did this for a project, and it also gets you a little bit of brand recognition if you are with multiple people at the conference. So the third part is also, we now talked a bunch of minutes about how to attract this thing. If you have this now, if you have the attention of people, don't hog it all for yourself. Make it also more easier for other people to stand out as well. And the one thing that we can do very well, there are other things as well, but one thing that you can do really, really easily is use social media. Social media has, and we talked a lot about this in the past couple of years, the dark sides of social media and so on, but it also has a bunch of benefits. Otherwise, it wouldn't be in the world. And there's a lot of ideas. What is the ideal social network for computer science or for our fields in computer science? So from my observation, people seem to like Twitter the most. There has been this interesting event by Dave Shepard at this year's ESEC FSE to put Reddit on the map. I don't know if it works out, but let's see. So Twitter seems to work for most people. you know. And the others like LinkedIn and so on, I found them to be a little less effective in getting word out, but your community might totally differ. And the thing about social media, and especially Twitter, is it's called social for a reason. There are different reactions that you can do, and the like isn't like a retweet. So in general, rule of thumb that I do is like a like, is like a pat on the back for the author. Ah, I've seen this, I like this, well done. Yeah? If you do a retweet, whether you comment or not, it's like getting on a soapbox and shouting, well, look at them, how great they are. Because all of your followers will see that tweet. All of your followers will add to the impressions of that tweet. But be careful who you endorse and what you endorse, of course. Always read what you retweet. And I think Twitter now forces you to do that, or at least like advises you, well, you're retweeting something without clicking on the link. Are you really certain you want to do that? Of course, you should do that. Be certain, like if you retweet, that's the same thing as saying, I would say the same thing, but this person is much more clever than I am. So how does the academic Twitter works kind of work? So the thing, how I do it is like follow people whose posts you like. Don't think about seniority there. If you find the tweets of another junior researcher entertaining, insightful, or just informative, follow them. If that person happens to be a very famous professor, go for it. But seniority shouldn't be kind of the idea here on Twitter, who you follow and who you not follow. And the other thing is, no one knows if you unfollow, by the way. So if you followed someone and said like, again, the same boring tweet about artifact evaluation, you can click unfollow. This person will never know. By the way, this is a piece from Olafur Eliasson that I took a photo of last year when ECO was in London. So that was great. So that's why we have non-virtual conferences are great, because you get to go to places and photograph art. So a bunch of things that I found working for me on Twitter that I've seen other people as well is, of course, pictures and hashtags. We read a bunch of text all the time. We are good at that. But if we want to go on social media, we are like everybody else. We like pictures. We like visual clues. And pictures get really, really much more attention than just a bunch of text. And even if you have a paper to present, at least show me the front page of your paper, because there's the abstract, and I can read the abstract without following any link. This is really good. And also be certain to link the conferences where you had this paper. Be certain to use the right hashtag for that conference. Sometimes that's hard to find out. The better social media teams make that easier for you, by the way. Also use a bunch of hashtags a little bit outside the box, so other people have this on their screen, because sometimes some people actually follow hashtags. I don't, but some people do. And always treat, so what I do with my Twitter account is I treat it as an experiment platform. So you're all a little bit like the people I experiment on without even knowing, and I check. So there's a lot of analytics going on in Twitter, and you can really see what's going on behind the scenes. So this is 2 tweets from 2019, from last year from me. So these had like very similar expression numbers, as you can see here, but the interactions were quite different. The first one was the one with the left, with the photo I took in the bathroom at ICSI. Actually, where someone posted their front page of a paper to a mirror in the bathroom for some reason. And the other thing is just a paper announcement. And the interesting thing is the interaction is what you want to get high, because this is where other people retweet you and other people see you and recognize you, click on your profile, say, who is this person? And this happened. Also, this tweet got a lot of retweets from a bunch of senior people, and because other people don't follow my advice with not following just senior people, and they just followed senior people, this got a lot of more impressions. But make your own experiments. Look what works for your community. So I had to find out, and I'm still learning every time I do something. Yeah, but keep in mind, this is from another field. This is the so-called purchase funnel. This is what salespeople use to kind of classify contacts. And of course, you have something like people that are aware of you, people that are interested in you, people that have some desire to work with you, and then the people that actually do it. Yeah? And as you can see, this number narrows down. This is true for sales, but this is also true for scientific collaboration as well. Keep that a little in mind to see. And if you, what salespeople do is they make the first thing as wide as they can, and then try to narrow it down. And you should basically do the same in doing so. Going a little bit away from Twitter, blogging, that's more time consuming, but this worked for some people. So Falian Hammonds is very great at that. By the way, I will upload these links and then you can upload the slides and then you can click on the links. So she's really great at blogging. She did live blogging for so many conferences. That was amazing. It's a lot of work, by the way, but that got her a lot of attention, of course. And I think this kind of work also pays back in the end. But as we're talking about publicity and leaving kind of the well-defined boundaries of science, is we need to talk about a little bit what can go wrong, because things can go wrong. Things can go horrifically wrong with communicating research results. And the one thing that I want to kind of sensitize you, no, I don't know. I have the German word in my head. I want to heighten your sensitivity for that a little bit, is that context matters. So you see this little nice curve, and I didn't make this up. This is actually a photograph that I took. It's actually this lobby. I don't know who designed this lobby, but I found this thing to be really emphasizing, yes, context matters. So the first picture was anything, and the other thing gave you a little bit of context. Yeah? So context always matters. So whenever you put something out there, be sure to put it in the right context and be sure to communicate precisely what you want and nothing. That's especially true if you have something that you're really excited about. So in Germany, a bunch of researchers had a really good breakthrough in breast cancer research. So they actually are working on a blood test to check for breast cancer. This would make some that you can really do in a large scale manner and that you can do on a regular basis without people having to go through very invasive procedures. And the problem with that is that the university communicated this a little bit prematurely and a little bit shortly. And especially on social media platforms like Twitter, where you have like a 140 character stream to fill, or 300, I don't know what the current rate is. This might happen to you as well. So sometimes it's really hard to shorten research inside. It's hard. It's even hard to shorten it to 10 pages sometimes. Yes, of course. But it's even harder to put it into 140 characters. What is the main thing your paper stands for? And in this case, the researchers failed because they actually had to retract that. The thing about that is that they had a very high false positive rate. So this blood test would really give you a notice, okay, you might have cancer in as high as rates like 46%. This is, of course, unacceptable, and this is, of course, not yet a breakthrough. It's very promising research. They did something that other people couldn't do before, but just because it was communicated so poorly, they had to retract that and stand in the public eye for some time as someone that did not do good research. And this is kind of my final word of warning for you. Whenever you do things, think about what could possibly go wrong, and try to communicate as clearly as you would in a paper, but in 140 characters. Thank you very much. Yes, okay, there's also my last slide. If you have like questions for this and other topics, especially on artifact evaluation, let me know.
Okay, thank you very much, Ben. So any questions?
Hi, can I make a comment more than a question? I like all this. I have like one counterplay of, don't write your papers full of advertising how wonderful you are, because that really turns off reviewers.
I fully agree.
Any other questions? So I'll start with my question. Ben, thank you really for the talk. So can you give an example for like where people get less recognition or collaboration opportunities due to them being not active enough in terms of self-marketing? And are there any telltale features where that indicate a lack of self-marketing among researchers?
That's a hard question, because I mean, how would I know? These people are not recognized, so I don't know them. No, seriously, I'm saying this out of my own history, as of course, because during your PhD you have all things in your head aside from being recognized as a cool person on Twitter, of course, and this is rightfully so. Yeah. Of course, that's what I said. Like the prerequisite for all of this is that you are a good researcher and that you have to do good research. This should be your first and foremost goal. But in the end, if you want to go on in your academic life and your academic career, you need to be recognized by other people, especially if you want to apply to a professor position at some point. You need to be known for some things. And of course, you need to publish on these things. This is the prerequisite. But it's interesting how conversations go if you added to your publication a little bit of extra. If you made that infographic that kind of summarized all of your findings, so people understand it more easily, and more people understand it in a very easy fashion. Think about this image that I had with the professor going from left to right. Yeah, and if you have like only 10 seconds to impress a famous professor, what would it be? Yeah, the so-called elevator pitch in a way, and social media is not that different. I don't have a poster example where things gone wrong, and I don't know if I should point out something like that, but yes, of course, some of my papers are, I think, maybe less cited because I didn't talk so especially about them, and these are like under-recognized, I think, for some things. Some things are rightfully under-recognized. That's okay, but some things, well, maybe more people should know about this. Yeah, but at that time, I didn't have the time to do it, or didn't have the motivation to do it. Sometimes that's sad.
I have a
Thank
comment.
you. Yeah, go ahead.
Is that okay? Sometimes I talk to students and with companies and so on about kind of a lack of an open source presence and building a profile in that space. So I was wondering what your thinking is around that.
Yeah, that's a two-sided sword. I know all of these. Some companies kind of have put it into their interview catalog, and they check for the GitHub profiles or the GitLab profiles of applicants. So this is something also to keep in mind. But on the other hand, I don't think that it promotes a good thing. So if you are a professional programmer and if you're working for a company and if you want to change jobs and the next company expects you to do some famous open source projects on the side in your free time, I don't think that's a good requisition from a company to have that. I mean, you should be recognized for your work you do on in your work time, of course, not everything that you do in your free time also on top of that. For students, I think it's fairly easier because you do have classwork to do. You can do that publicly. You can learn with adding to open source projects, and you can make your research open. This also benefits the research community, by the way, but also gives you a nice GitHub profile to look at.
Can I just have a comment on that? That sometimes these things align, and I was thinking that, especially with artifact evaluation and the code that we share, it seems like an opportunity where you can kind of show some of your skills, as we kind of all share open source code anyways. So that's kind of what I was thinking. I'm not so much thinking about the moonlighting activities where you go and do things in your spare time. And then also in work, I mean, in work settings, you may actually be working on open source, I guess. But mostly a comment, but it seems like there's an opportunity there as well.
Of course, there is. Definitely. And one thing about artifact evaluation, in our minds as researchers, artifact evaluation and open source and open science is kind of aligning, and it rightfully is so. But for artifact evaluation, it's not really required. You can actually go through artifact evaluation without, in the end, publishing the artifact in a public scale, but just making sure that some other person peer reviewed your artifact. That's also possible if the situation requires you, especially if you do research with companies. At some points, I see people hesitating from submitting for artifact evaluation because they think, oh, well, then I have to make it all public. Not really true. In some cases, yes, but in most of the times, this is not the requirement. And then you can actually get like these nice badges and the certainty that some other people confirmed your results as well.
Thank you.
I have a question, if I may. Ben, thanks for the talk. It was really, really interesting. I agree with virtually everything you said, but personally, I'm not that happy that I agree with it, in that I don't know what being an academic in computer science was like in, say, the 1980s. Maybe Doug can tell us a bit about it. But I just have this feeling there was more time for scholarship. You may have had to get papers mailed to you. You could only read a certain number of things because only a certain number of things were available to you at any one moment. There were not all these opportunities to promote yourself, so you didn't have to because you couldn't, and no one else could either. So my question for you, Ben, and then I'd sort of be interested to know what Doug might think about all this is, are you glad that there are all these things one can do to promote oneself, or do you see it more as a sort of necessary evil because you can't succeed in your career unless you do it?
I don't know if it's actually this important that I cannot succeed without like a successful Twitter presence. I don't think we're at that point yet. I mean, people are successful without any social media presence at all, and this is good. I mean, yes, the old times where you had to write like extensive letters, and these letters had to be carried by a courier on a horse, so they took a bunch of months until you actually get a reply. I have these moments where this feels like the ideal setting, where I said, like, okay, I can like take my 3 months to work on this particular thing, and no one will bother me with puny things like replying to a tweet. Of course, this is very tempting, But on the other hand, it has a bunch of benefits. So I had a bunch of very good discussions on science, on particular aspects of science, sometimes also on policy, by the way. This is getting increasing that policy discussions for conferences are made public on Twitter, strangely, but it is the case. That's also transparency, that's nice. And of course, yes, of course, in the end, it takes away from your time. And I think time management is, in contrast to previous days and previous, also in computer science, previous days as a researcher, has become incredibly more important. So you need to really, I mean, you can lose days and months in Twitter if you like, and have the feeling that you participated in science. In the end, you didn't publish anything, and you didn't achieve anything. That's possible, and you need to kind of lay some rules out for yourself. So, okay, I'm not going to spend the whole day browsing for these answers on Twitter. Of course, this is something we hadn't had to do before. And yes, that's not necessarily good, but in the end, also a lot of benefits come out of that.
I guess people are waiting for my reply to that. Yeah, I think the battle days were worse in that that there's greater equity. Anybody can become an instant YouTube star. Well, anybody can become an instant celebrity in the world of PL by having a good idea wherever it's from. And that's a good thing. And the price we pay for it is that, focus and attention are scarce commodities these days. It's harder to do things in a sustained way when you are, okay, every hour or two checking 538 to see what the polls are, because you can.
Yeah.
That's all I have to say.
And I see that Guido Savaneschi is actually wearing the T-shirt that I've shown. I haven't noticed that before. Great. Being on brand.
I'll take the liberty to ask a question then. So I see more and more Twitter profiles belonging to groups, organizations, universities, even research projects within universities. And what do you think is the role of these profiles? So do they promote researchers? Do you think there is a tension between, the researchers' recognition and institutional recognition, so to say? Can you comment on that?
I think I can. I have a distinct opinion on that. So I do follow some university accounts, especially my own or my previous employers, to kind of follow what they are working on. Sometimes I found like research group accounts quite interesting, if they're quite close to me. I usually don't follow project accounts so much because they are either incredibly boring from my view, or they don't post a lot. They have this odd, well, we published a new version of our tool post, and then you hear nothing from them for 3 months. So you literally forget them. While when there's a person behind that, I can see an opinion, I can see a bunch of related information that is kind of relevant to me most of the time, sometimes not, of course. And I have the impression that I'm at least having a conversation with a person. I think like these accounts, these institutional accounts make sense for reaching a broader audience, especially if it's like a complete university. Then of course this account has a lot of followers that have nothing to do with the university, that just want to keep up with research. And if you have, and these are parts of the marketing efforts done by your university. And these make sense to me. These totally make sense to me. When it comes down to research projects, if it's a really large research project that's relevant to me, and if they really do an effort and have a person like curating that, that might be interesting. But usually people just make an account for their project and then they tweet about this project and they are really putting effort in the first few weeks and then they really drop silent. And I don't know where the point is.
Any more questions? Okay, great. So we'll have a short 10-minute break, and then we're going to have the last talk today given by Alistair. So please stick around. And if you have any more questions, you can always talk with Ben in the Zoom chat.
Can I ask one more question, because I think it might be
relevant? Of course.
Yeah, just a brief one. Ben, what would you advise students about how often to participate on artifact evaluation committees? I know from my students that it's been quite a mixed experience. It can be a great thing to do. It's a big time commitment.
It is.
For career, I mean, like selfishly, if you're being sort of somewhat selfish, how good for your career is it to do them?
I don't know how good for your career is. I mean, you get recognized, you are in a committee and you participate in peer review. So that's always a good experience. Also, in artifact evaluations, you have the distinct pleasure of looking at other people's implementations and seeing, well, mine isn't so bad. Because as research, especially as junior researchers, we are perfectionists, and we look at that and say, I can never submit to artifact evaluation. This looks, if someone looks at this source code, I will lose all of my dignity. No, of course not. It's research code. It's most of the time hacked together in a night session. We all do that. It's fine. At artifact evaluation, we just need to make sure that it's documented in a way that other people can actually run it, that it doesn't blow up in your face. And for this, artifact evaluation is a good way of getting rid of that syndrome of being a perfectionist in your engineering tasks, because this usually doesn't help a lot. On the other thing, I think artifact evaluation currently as we do it might not be doing the thing that we think it does. So we're still not certain why we're doing artifact evaluation. One of the outcomes of my study. We do have a sense that it helps to it might help replicability of our results. We don't know that yet. And for this, it is a lot of work. So I don't think as a PhD student, you should do it like, it's hard to give a rule of thumb, but don't overdo it. I mean, participate in 1 and 2. There are a lot of PhD students out there. There are a lot of artifact evaluation committees out there. So do like 1 or 2 in your PhD time. This should probably be enough to have a learning effect for you and be a service to the community and be visible. But don't do it every year. And don't do it 3 times a year, because it's a very straining process. And I did a bunch of artifact evaluations myself. You spend a whole week, and in the end, you don't know. And currently, as it's not a thing where it's a totally voluntary process, at the end, you might get that feeling that your voice didn't matter as a reviewer. We heard that voiced a lot in our survey. And this is not necessarily a very pleasant thing. If you think that your effort as a reviewer is not heard, and then a paper where you found that the results actually don't replicate, gets accepted, that's not a good feeling. And so we're still figuring out the process currently, as it's kind of our most newest peer review process, I would say, in the computer science field. And we're still trying to figure out what that thing actually is, what it's for, and how it should be done properly. And so don't over expose yourself to that experiment, but participate.
Can I ask a quick follow-up there? Do you think that artifact evaluation will sort of move towards being happening earlier, given the case that you just gave?
Maybe. That's up to the communities to decide. I can't predict that. I think it might. I think we might move into territory where artifacts, I mean, we actually do. So if you look at PLDI this year, they told me they had like from 70 accepted papers, they had like 60 artifacts. I mean, that's brilliant. That's great. But we're moving into territory where artifact submission gets to be the norm rather than the exception. And then we get into territory like ICST does it this year, where they actually, or next year, I think, where they actually want to have a sentence of explanation from you if you don't submit an artifact. Mm-hmm. I think we're moving there first, and at some point it slowly creeps into normality, and we will all do it anyway, quite naturally. I don't know if the evaluation process as we do them will be still the case. I think they also will be a little bit adapted.
Oh, I see someone already mentioned. Alistair's talk is in an hour, or yes?
Yeah, sorry, I just made a mistake. So we've still got 1 hour and 5 minutes before Alistair's talk. So we've still got plenty of time for discussion if you want.
I am out for then.
Yeah, so to all the juniors, do artifact evaluation, at least participate as a submitter. It's really worth it. And I got comments on artifacts. So people approached me and said, oh, thank you for doing an artifact there. It really helped my research. And this is a great feeling, because previously, I mean, there was this burden. You looked at the paper and you're like, I have to write this person an email, and if they still have it, and so on. So a lot of research artifacts were kind of lost because people didn't archive properly. And that's especially true when you are a PhD student, and when you leave the academic field at the end of your PhD, when you received your PhD, when you graduated. Why should you care about research after that? That's kind of an open question. So having artifact evaluation like normalize the archival of these things and kind of harmonize and standardize it in a way that we all know how to do it and all know where to look. And this is the real benefit that actually might have the most impact. We'll see that. We don't know that yet. It's still too early to say. But I think we're on the good way there. As to the higher goals of replicability and reusability, I hope we'll get there. I most certainly do. We don't know that yet, and let's keep artifacts pumping out artifacts, because we do them anyway. I mean, you work on that anyway, and you might as well just upload it. It might be helpful for someone in the long run. You don't know that before, and you don't know if someone can reuse this. They might be able to.
Okay, thank you very much, Ben. And do we have any more questions? If no, we'll close this session for now, and we'll have an 1 hour break and until the next talk. Yeah, thank you very much, Ben.
Thank you.
That looks beautiful. Look at those graphics.
Spoiling what's coming up by having.
Oh, it's just it's a teaser. Wow, that's great. Thank you.
The rest of the talk's all Greek letters after that, I'm afraid.
Excellent.
Clever to start with the graphics to catch the attention.
You'll be able to tell who made which invited talk slides just by a chroma analysis.
Now there's a great PhD topic. We should give it a couple more minutes here, if that's okay with you, Alistair.
Yeah, that's fine.
Terrific. Absolutely. Thank you. It's so strange not to have people running from other rooms or anything.
I know, yeah. Have you been enjoying the rest of the conference?
Wow, you know, it's so strange but wonderful. How about you? I
have been, yeah. I've dipped in and out of it, and the bits I've dipped into I've really enjoyed.
Yeah.
It's been, I feel slightly ashamed to say this, but I'm submitting a paper to PLDI. Well, I'm not ashamed about that, but I'm ashamed to say that the clash with the PLDI deadline has definitely detracted from my enjoyment of the conference.
Yeah.
Yeah.
Timing is everything, isn't it?
Yeah.
Well, it's really generous of you to take your time to give this talk today.
Oh, my pleasure. It's really nice to be invited, and yeah. And I've enjoyed the whole day.
So we do have a very action-packed last session here, where we get to have this incredible talk from Alistair. We get to see some sneak preview of these slides. And then, you know, this is the roundup after this, which is absolutely amazing. All the people that dedicated their time today to help out students with these questions, and certainly to have this coming together of eCoop and Splash. What a great, I think, a really great opportunity for us to get everybody together like this. And that roundup it's a lot of people, but and it's going to be pretty quick, but it'll be hopefully sort of the takeaway thoughts from our academic panel at the end here. So I think whenever do you think, should we give it a little bit more time, Alistair?
I'm happy either way. Yeah, we can give it a couple more minutes.
Let's do it. Okay. Well, since it's not as though people have to, you know, fight for seats or anything today, if you're comfortable with getting us started, Alistair, that would be great. Thank you very much again for doing this talk. Really looking forward to this. And again, wow, this look at those pictures.
Cool. Okay. Well, thank you very much for the invitation to speak at the doctoral symposium, and thanks very much to all the students who submitted your fine work to the symposium. Hope you've had a good day. I'm Alistair Donaldson. I'm a professor of computing at Imperial College London, and I'm also a software engineer at Google. And I'm going to talk to you about a project called Graphics Fuzz, which is about metamorphic testing of graphics drivers, and we're in particular applying it to Android graphics drivers at Google. So in this talk, I would like to do two things. One, to tell you a bit about the technology behind Graphics Fuzz, and two, to tell you a little bit about how Graphics Fuzz went from being an academic research project to a startup company that then Google acquired. And I would love to answer questions during the talk as well as after. So if you have any questions during, please feel free to interrupt. Do interrupt me mid-flow. It's much harder in these Zoom talks to know when it's appropriate to ask a question. So I want to tell you now, anytime is appropriate. And of course, I'm happy to take more questions at the end. So suppose that you were a graphics developer and you wrote a little program to render an image like this. And you ran it on your graphics driver, and instead you got an image like this one here. So looks kind of cool still, but it's not the image you wanted. That would not be good. Maybe you had a graphics program to render a galaxy like this, but instead your machine blue screened. That wouldn't be good. And perhaps worse still, suppose you had another nice image you wanted to render, and you were doing this in a web browser using WebGL, which is a technology for letting you do graphics rendering from JavaScript. If instead someone visiting your page could instead get this be rendered from another one of their tabs, then that would be very serious, right? Because you could make your web page malicious and you could capture data that was being rendered supposedly to another one of their browser tabs, but that was actually being captured by your web page. So these are all examples of some bugs we found using the Graphics Fuzz project, where a graphics compiler has a bug that leads to either an image being rendered wrongly or leads to the graphics driver getting into some kind of bad internal state that can bring down a whole system, or leads to the graphics driver leaking graphical data to the wrong place, which is a potential security exploit. And actually my PhD student, Paul, got a Chrome bug bounty for this particular exploit shown here. So what I'm going to tell you about is our technique called Graphics Fuzz, which finds bugs in graphics drivers using a method called metamorphic testing. And in particular, it finds bugs in the compiler components of graphics drivers. All graphics drivers contain one or more shader compilers, which are responsible for compiling programs called shaders that are designed to run on graphics processing units. So to give you a bit of terminology that I'll be using in the talk, there are a couple of ways of doing graphics programming, and two popular methods are using the OpenGL-ES API and the Vulkan API. And what these APIs do is they orchestrate a bunch of operations on your GPU device. And the programmable aspect of the GPU is controlled by shader programs. They run across the many cores of the GPU hardware and either cause things to be rendered to the screen or cause computations to be done between buffers. So if you're familiar with CUDA or OpenCL, then a shader is kind of like a kernel in those programming models. And the OpenGL programming model has a shading language called GLSL, the OpenGL shading language, and Vulkan has a shading language called SpearV, which is an intermediate representation. Okay, so what we are doing in this work is automatically testing shader compilers, and we're doing it using a technique called metamorphic testing. And I want to explain how metamorphic testing works for testing any old compiler, not necessarily a graphics compiler. Suppose you've got some program P, and let's imagine that P is a well-defined deterministic program, so that when you run P on an input, you'll get a well-defined output. Well, if we compile the program P into an executable E, and then run that executable using an input I, then we'll get some output, which we can assume is well-defined. We don't know a priori what the output O is going to be, but we know that there will be some well-defined output. If we can then apply transformations to the program P that preserve its semantics to get a program P prime, so maybe refactorings or optimizations or obfuscations, then if we compile P prime to an executable, then the executable will be very different from E in its object code because we've compiled a different program. But because the programs are semantically equivalent, if we run both E and E prime on the same input, then we should get the same output. And if we don't get the same output, then there's a bug in the compiler. So if you know about metamorphic testing, we've got a metamorphic relation here that says when we compile and execute P, we get the same result as when we compile and execute P prime, as long as we use the same input. So this gives us a way to solve the oracle problem for compilers, where we don't know when we have a program and an input to that program. We don't have a reliable way of knowing in advance what the correct output for that program and input is. Having an oracle for that output is essentially as hard as building a compiler, which is the thing we're trying to test here. So we get around the oracle problem by actually comparing the results that we get from compiling and executing multiple distinct programs. And if we get different results, then we know that the compiler can't be correct. We still don't need to know what the result should be. We just know that these programs should give the same result. And if they don't, then there's a compiler bug. Before I move on, does anyone have any questions about that? Does that make sense as a concept? Okay, I'll take your silence as assent. So this technique, metamorphic testing, has been used in many domains, but the first instance I saw of metamorphic compiler testing is from a really nice paper from PLDI 2014 from researchers at that time based at UC Davis called Equivalence Modular Inputs. And this is an instantiation of what I showed you on the previous slide. What they did, which I think was very clever, was we'd take a program P and compile it, and then they would profile the program on a specific input. And that profiling would give a partitioning of the program statements into the statements that are covered by the input. Let's call those, well, we'll give those a name. There are some statements that are covered by the input and some statements that are not covered by the input. And we'll call these statements that are not covered by the input D for dead. So these statements of the program, they might not be dead code in general, but they're dead with respect to the input I. So now what the researchers did is from a program, P, they would manufacture a whole load of programs, P1, P2, P3, etc., that differ only in these statements D. And what they did in their original paper was actually just randomly deleted statements from the dead portion D. And although these programs globally might behave very differently, on the input I, they should behave in precisely the same manner, assuming that P doesn't trigger undefined behavior on I. So if we compile all of those programs with a single compiler and execute them all, then if we get our result, this 42 here, that differs from the other results, then we know there must be a bug in the compiler. And very likely this program P2 is the one that's miscompiled. Of course, in theory, it could be the only one that gave the correct result, but that's very unlikely in practice. But the point is, a result mismatch points to a compiler bug. And this method was really successful in finding a whole lot of bugs in the GCC and LLVM compilers, and various evolutions of the method have been successful since. In fact, the researchers were acknowledged in the LLVM4 release for their bug finding effort. Okay, so what we're doing in the graphics first approach is inspired by this work. We've gone a bit further, and rather than doing profiling and finding code that can't be reached by a certain input, we've devised a whole load of transformations on the graphics shading language, OpenGL, or GLSL is the name of the shading language. We take an original shader and convert it into equivalent form. So we take an original shader program, we push it through the graphics stack to get an image, and then we apply a whole load of semantics preserving transformations that we've implemented in a compiler framework to get a stack of variant shaders. And each one of these variant shaders should render the same image as the original shader when we push it through the graphics stack. So if they all give the same image, which they should do, then that's fine. We haven't found any kind of bug. But if we get a different image from one of the variants, or if we get a crash, then we found a bug in the graphics driver. Now, I should clarify a little bit here that graphics hardware uses a lot of floating point operations, and floating point operations are sensitive to round-off error. And graphics programming languages are very relaxed with respect to what compilers are allowed to do with floating point values. So actually, the point here is that if we see a radically different image from one of our variant programs, that indicates we found a compiler bug. If we see an image that differs in just a few pixels, we can't say conclusively whether that's acceptable or a compiler bug because the language is vague with respect to floating point. So in our work, I'm not going to go into the details of it here, but we have some methods for estimating when we think an image is wrong enough that it probably stems from a bug in the compiler rather than from legitimate rearrangement of floating point operations that can lead to some small differences in an image. Okay, so this is how graphics fuzz finds a bug. Like I said, it's inspired by this EMI technique from PLDI 2014. But the transformations we've implemented are quite specific to the graphics programming model. Is it useful though? So if I find a bug with graphics fuzz and get some crazily transformed shader program like this, and I say to a GPU compiler maker, there's a bug in your compiler, trust me, there is. This crazy program should produce exactly the same results as the original program. Good luck detecting it. Well, no, that's not going to be very useful. First of all, it may not really be very actionable to be given a small program and a massively bloated transformed program. Even if the transformed program should be equivalent to the original program, how as a compiler developer are you going to start working out what is actually wrong? Second, graphics fuzz is itself a complicated tool that will be prone to bugs just in the way that a compiler is prone to bugs. So there may be bugs in graphics fuzz, and this bloated program may not truly be equivalent to the original. So it could be a big waste of a developer's time to go and investigate this bug that I claim to have found. So to counter that, we use test case reduction. We've got our original shader, and we've got our bug triggering shader that was manufactured by applying a whole load of these transformations. And because we applied the transformations with our tool also knows how to reverse the transformations. So what test case reduction does is it keeps trying to reverse some transformations, each time checking whether the resulting shader program still triggers the bug that we found. So it gives the same crash, or it still triggers a bad image, an image that's substantially different from the image rendered by the original shader. And we do this until we find we can't remove any single transformation without the bug disappearing. And what this gives is a small bug triggering shader that differs only slightly from the original, that still triggers the bug. And the pair of the original shader and the minimally different shader are a really good starting point for compiler developers to go about diagnosing and fixing the bug. And we've reported many, many bugs over the last few years to developers. And this small diff format has proved to be very successful for them being able to act on the bug reports. Here's an example of a wrong image compiler bug that we found near the start of the project. And the diff is shown on the right-hand side. So there was a piece of code that returned the result of a call to default color. And what our tool did is many things, but after reduction, after reversing the many things it did to find a minimal difference, we found that wrapping this return statement in a switch on the value 0, with one case saying if 0 is 0, then return default color. This transformation, which is evidently semantics preserving, was enough to trigger the bug. So often the differences that we get after we apply fuzzing and then apply test case reduction are very small and very actionable. Here's an example of a crash compiler bug that was found in a vendor driver. So when graphics fuzz finds a bug that leads to a shader compiler crashing, it can be much more aggressive in its reduction. It doesn't need to preserve equivalence with the original program. It can just shrink down the program as much as it possibly can to try and find the smallest example that triggers a bug. Here's a slightly more interesting and more recent example. The details of the program don't matter, but the point is you can see on the left-hand side a small bit of OpenGL shading language code and this triggered an assertion failure in LLVM's AP float module for arbitrary precision floating point arithmetic. Okay, so that's an overview of the graphics fuzz technique and how it works. And I now want to tell you a little bit about how this started and how it led to a startup company, which then Google acquired, before I tell you a bit about how we've been rolling it out at Google. Before I do that, does anyone have any questions regarding the technical material I presented so far? Okay, well, the project started around about October 2015. Like I mentioned, we were pretty inspired by that work from PLDI 2014, and we had a go at implementing something similar, but different, because we had to have a different take on it to overcome some of the specific difficulties of applying it in the world of graphics. And the first thing I want to say is, actually, with research, it can often be the case that a not terribly novel idea can go a long way. So this was something where, rather than thinking, I've dreamed up some clever idea of my own, I read this paper and thought, that's really cool. I wonder how hard it would be to try that in a different domain, and I wonder how well it would work. And that's what has then taken me on what's proved to be quite an interesting journey that's led to this startup company and successful acquisition by Google. So the point I want to make is, don't feel that you always need to be doing research that's supremely novel. If you can, and if you enjoy doing so, great. But also, there are many ways to have a fun time and dabble with interesting technologies by looking at what other people have done and seeing if you could apply it in another interesting domain. So in October 2015, we started building an early prototype. And I vividly recall being on a train on the way back from London to the countryside where I live, and running like the first batch of tests from this tool on my laptop, and my laptop becoming completely unusable. And I tried to take a photo of it. It didn't come out very well, but on the right, you can maybe see this is Windows, and there's all kinds of crazy stuff going on the screen. And actually the laptop was flashing and flickering thanks to running some tests that had caused the driver to go into a pretty crazy state. And this was the first time I thought that I'd done some research that maybe could have some commercial potential, because it seemed really serious that by running just a small number of these fuzz tests, I could make my laptop become essentially unusable. I needed to restart it before it would get back into a reasonable state. I thought, this might be something that could have some serious impact. We published a short paper about the idea at the Metamorphic Testing Workshop in 2016. And that's only a 4-page paper, but actually, because the approach is very simple, I already told you about it in a few minutes, this short paper actually contains most of the main ideas behind the approach. Then we implemented it, really rigorously and started to do some large-scale testing. And what we found was that we could find bugs in the drivers from all of the GPU vendors whose devices we tested. And this is another thing I wanted to say about research is that if you're doing something that isn't as novel conceptually, to some extent, when you're trying to get your work published, you can compensate for that by doing a really thorough evaluation. So if you've got a simple idea that you're excited about and you can show that it works really, really well in practice, that can often overcome some grumbling from reviewers about how this is not the most novel thing they've seen this year, which you might get if you don't have such good practical results. So actually, the reason we found bugs across all these GPU vendors was not because we set out to do that for its own sake, but because we'd enjoyed working on this project. We wanted to publish it at a top conference, and we knew we could only do that if we had a big evaluation. So we tried it on all the devices we could get our hands on, and actually it turned out to work surprisingly well. And yeah, we figured that this would actually be of interest to many people in the graphics world, not just to PL academics. So we started blogging about the work via Medium and promoting it via Twitter. And going back to Ben's really nice talk from the last session, I think that you can get a lot more attention if you do some blogging and promotion on social media for your work than if you just write plain academic papers. I wouldn't necessarily recommend doing this for all of your work, but if you've done a piece of work that's a bit more practical than usual, that you think might have appeal to software developers in general beyond academia, then I think doing blogs and doing social media promotion can really get a lot more people to know about it. Then we started to really get the bug for doing something commercial. We thought, you know, this really could be something that the industry would find useful. There may be potential for a startup company. And it coincided with the UK government offering a scheme for academics interested in pursuing the commercial potential of a research idea. This iCure program provided funding for my former PhD student Paul and my then postdoc Hugh to travel the world and have dozens of meetings with a whole bunch of companies like Apple, Imagination, Intel, Google, Samsung, various others. And the clear message from engineers at those companies was, we like what you do, but for our management to buy your stuff, you would actually need to make yourself a problem, really make it be that your testing technique is showing the deficiencies in all of these GPU drivers that, that people around the world depend on. And if you can show that, then they will know, you know, this is a problem we have to fix, partly because we should fix it from an engineering point of view, but maybe more importantly from management, because it will be pretty bad looking if we don't take it seriously. Then we qualified for the next stage of this iCure program, which was called Cyber ASAP, the Academic Cybersecurity Startup Program. And that gave us some funding to build a product, like a really productized version of Graphics Fuzz that we could potentially sell to industry. Now, at this time, I really did not want to start a company. What I wanted to do was to see whether we could have this technology work really well and sell it via the university. So say, you know, it's here, we do some promotion of it. Companies can pay for it if they want it, but they get it via a license from the university. Maybe I would get some money thanks to that license, but more importantly for me, I would get to know from a curiosity point of view whether companies would buy this technology. For me, that was more important than particularly making money from the technology. And at the time I was, you know, very happy in my academic career. My wife and I were expecting our third child. The idea of starting a company really didn't seem very appealing. However, I soon found that this idea of trying to license things to the university was pretty naive, because trying to sign non-disclosure agreements, NDAs, between universities and companies, at least at my university, but I think this is the case for many people, is a complete nightmare. Basically, the university contracts department, their job is to try to minimize risks to the university. And when they get one of these non-disclosure agreements, they want to look at it really carefully and start to try to negotiate it. But actually in industry, people sign non-disclosure agreements all the time. It's a very standard thing to do. The agreements are usually very simple. They don't carry that much force. You just need to sign them before you can get a conversation going. So what we found was we'd be talking to companies who were maybe interested in Graphics Fuzz, and they'd want to sign an NDA before we could talk further to see if they were potentially a bit more interested. And then weeks or months of negotiation with the university around the NDA would commence. And this would actually be kind of expensive for the company in terms of legal time, rather embarrassing for me, because the contact I had at the company would be getting kind of annoyed that they couldn't talk to us, or maybe annoyed that their legal department were having to be involved. And it just didn't really work at all. So actually, I first planned to start a company more so I could have a vehicle that would allow me to have a license to the technology from the university and allow me to take the personal risk of signing these very benign non-disclosure agreements, still with a view to talking to these companies to see if they would be interested in the technology and not particularly pushing it as a product. It took a while to actually negotiate all the details with Imperial Innovations to get a startup company going. Partly because software license terms are genuinely hard and universities don't have that much experience in software licenses. In the meantime, we got our top paper about Graphics Fuzz at UPSLA, thanks to this big experimental evaluation. And we started to get quite serious about doing a company. I think we started to really get the bug to the point where we got a professional logo design, this logo for Graphics Fuzz you can see here. And having seen Ben's talk, I really regret that we didn't get stickers made. I think Graphics Fuzz stickers would have been a really great idea, maybe not too late. And then when we did launch the company, suddenly we thought, you know, if we're going to do this, let's do it properly. Let's try and really make our technology known. And we started to do some higher profile blogging and social media promotion of our product rather than our academic research. So we had a product, which was a test suite that we were trying to sell. And we had these blogs where we would do comparative studies of devices from with GPUs from different vendors, showing how well they performed on our test suite. In our blogs, we would show big tables of results where we would have like lots of different vendors and rows of test results. And these grids should, if everything was working, all have exactly the same image everywhere. But we would actually show that for various vendors, we would get memory corruption, or we would get link errors or compiler errors. And we finally finished spinning out the company. We started doing this promotion actually before the company was fully spun out because we got kind of impatient. And then relatively quickly, Google were interested and we were acquired by them in August 2018. So that's a bit of a whiz through the graphics fuzz journey from academic research project to startup company acquired by Google. And I suppose, you know, if anyone does their own startup, their experience will be completely unique. But the main things I would say from my experience is don't be afraid to give it a go. Don't necessarily think you've got to get all the I's dotted and T's crossed with your university before you can start trying to promote the technology. You know that these negotiations with the university will eventually work out. And if you can get people interested in the meantime, that can actually give you something you can use to try and speed up negotiations by pushing a bit harder. And again, don't feel like the idea you choose to commercialize has got to be your most intellectually interesting idea. I've worked on projects that I think have been much more intellectually stimulating than graphics fuzz, if not as fun to code, and if maybe they don't have as fun visual results. But I've worked on like invariant generation for formal verification, which was like very intellectually stimulating, but has way less potential for a commercial endeavor than something more simple and effective like graphics fuzz. Okay, and we kept the source code closed when we were doing this company, but as soon as we joined Google, we were able to open source it because Google really wanted to be able to use the technology for the good of the Android ecosystem, and have it be open source made more sense than trying to keep it closed. One thing I wanted to say regarding artifact evaluation is the 2017 paper coincided with us trying to spin our company out and having lots of IP discussions. And at that time, we just didn't feel too comfortable sharing the graphics for source code with anyone, even artifact evaluation reviewers. So for that paper, we provided programs generated by graphics fuzz in lieu of actually providing access to the artifact. And I remember getting our artifact got rejected, and I think it was fair enough because we didn't give the reviewers the means to properly evaluate it. And one of their comments was, I think it's completely fair that they want to keep their tool private if they are thinking of commercializing it, but they can't get an artifact badge if they're going to do that. So yeah, that was our lack of artifact evaluation for graphics fuzz. But the tool is now open source and very easy to use. Okay, and what I'll talk about for a bit more is what we're doing now at Google, testing Android graphics drivers. Gaming on mobile devices is becoming a bigger deal as the years go by, and mobile graphics needs to be reliable. OpenGL is the legacy API for graphics used by a lot of games now, but modern graphics is moving towards this newer API called Vulkan. So when we joined Google, our mission really was to make Vulkan graphics drivers as reliable as possible by finding bugs using our fuzzing techniques. But the trouble is that our technique, graphics fuzz, worked on the OpenGL shading language. It didn't work on Vulkan's SPIR-V shading language. But luckily, we were able to work around this by using a translation tool. What we do is we take an OpenGL reference shader and we transform it using graphics fuzz to get one of these massively mutated variant shaders. And then we push both the reference and the variant through a front end called GL Slang that, among other things, is able to turn OpenGL shader programs into SPIR-V shader programs. So we do this for both the original shader and the variant shader. And then we can feed them to a Vulkan driver and get an image that we can compare as before. So by leveraging this cross-compilation tool, we were able to take our technology that works at the level of OpenGL and use it to test Vulkan drivers. This has some pros and cons. I mean, one pro is that it let us use the technology that we had brought with us to Google. Another pro is that GL Slang itself is an important tool that many people use, and we've been able to find some bugs in that tool and get them fixed. And also because many people are using GL slang, the kind of code that you get when you go from OpenGL to Vulkan via GL slang is important. That's a path that many people will be treading. So if we can find bugs in that pathway, then that's valuable. A clear downside, though, is that there are going to be many things that one can express in the Vulkan shading language that GL slang will never emit. So by feeding GL slang programs and depending on its translation, we're never going to test aspects of the Vulkan driver that GL slang is incapable of generating code for. So this has been a good way to get started, but there's a lot of scope for doing deeper work directly at the level of Vulkan. What we do when we find bugs is we use them to strengthen the Android compatibility test suite. This is a test suite that ships with every Android dessert release. So the Android versions traditionally have been named after desserts like marshmallow, nougat, Oreo pie, although they changed the numbers from Android, would have been Android Q, they called it Android 10. And every dessert release has got an associated compatibility test suite. And if you want to make an Android phone, then if you want to be an official Android phone, you need to demonstrate that you pass this compatibility test suite. And new and more rigorous tests can be added to the compatibility test suite for future Android versions. And what we've been doing is we've been adding tests for bugs found by graphics fuzz continuously to the compatibility test suite for the first Android Q, then Android R that was recently released. And right now we're adding tests for the Android S compatibility test suite, which will be frozen sometime early 2021. And what this does is it ensures that the associated bugs will be fixed. Something that I hadn't appreciated until I joined Google was that there's a really long journey from a graphics driver being built at some company like ARM or Qualcomm, both of whom make quite widely deployed Android graphics drivers, and actually making out to an end user device. It can be the case that it can be months or even a year before a bug fix actually gets shipped to a user's phone via an over-the-air update, not because it couldn't be shipped sooner, but because doing an over-the-air update is quite high risk, and phone makers want to try to limit the extent to which these updates are needed. So if you put yourself in the shoes of a phone maker, you're kind of treading a fine line between wanting your phone to work as well as possible and be as reliable as possible and wanting to avoid the horrors of an update going wrong and maybe wanting to minimize the expense of doing an update. So if we just reported bugs, they might get fixed by driver makers and make it into new devices, but they might never get, those fixes might never get shipped to older devices. And by adding tests that expose the bugs to the compatibility test suite, we actually make it so that a device maker can't qualify for the next Android unless they ship drivers that fix these bugs. So it's a good forcing function, not for bugs to get fixed, but for those fixes to be rolled out to older devices, not just to new devices. Something completely different we've been doing at Google is actually using our metamorphic testing approach to find vulnerabilities in the Chrome web browser. The Chrome web browser is really widely used, and therefore loads of people are trying to attack it. And there's a project at Google called ClusterFuzz, which is a continuous approach to fuzzing the Chromium browser using a combination of sanitizers. So Chromium gets compiled with address sanitizer, memory sanitizer, thread sanitizer, and other tools like that, meaning that when you run the browser, various errors that might not be picked up by regular usage will be flagged as bugs. And then coverage-guided mutation-based fuzzing using libfuzzer, which is a bit like the AFL tool, to make mutations to inputs that you're feeding to the browser and see whether the mutated inputs can trigger security-related issues that these sanitizers pick up. Well, how does graphics fuzz fit into this? As I mentioned earlier in the talk, there's a technology called WebGL, OpenGL for the web, and that's implemented in Chrome. And WebGL vulnerabilities are therefore a concern. However, the Chrome security team don't really care about the kind of bugs we've been trying to find with graphics fuzz, wrong image bugs, where the compiler has silently generated wrong code. What they care about is exploitable vulnerabilities. So it's not like that they think wrong image bugs are okay. It's more that if they're not exploitable, they're not a major concern for Chrome. It would be nice to have them fixed, but it's not critical. But exploitable vulnerabilities are crucially important. They must be fixed. So how does metamorphic testing fit in here? Why couldn't we just do mutation-based fuzzing to take some WebGL workloads and apply random mutations that might make them completely invalid, but nevertheless, they might trigger exploitable vulnerabilities that could be fixed? Well, the way mutation-based fuzzing works is you take an input and you mutate it in a very straightforward manner that might not make it be valid anymore. So you have some initial test that goes all the way through the system you're testing. If it's a compiler, this test would go all the way through the parser, type checker, optimizer, and code generator. And if you had some other layered system under test, it would get all the way through these layers. And now you mutate it to get some input, T2. But that input is almost certainly invalid. It will almost certainly be rejected by the parser of your system under test. It may find an exploitable vulnerability in the parser, which is really good news because the parser is the first thing attackers will target. So if you can fix vulnerabilities in the parser, that's really good. But it's not very likely to find bugs in, say, the type checker, and it's extremely unlikely to find bugs in the optimizer, and even less so in the code generator, because it's really unlikely that a randomly mutated input will be valid enough to make it through to the back-end stages of the compiler or the deeper stages in some other layered system under test. In contrast with metamorphic testing, where we transform these inputs into equivalent inputs, an original valid input gets transformed into a mutated valid input. What that means is that we generate many, many tests, all of which get through to the back end of the compiler or to the later stages of whatever other layered system we're testing. This is great in that it may mean we can find exploitable vulnerabilities in deeper parts of the system. And it has the deficiency that because we only generate valid inputs, we won't find vulnerabilities in, for example, error handling code, because there shouldn't be any errors from these test cases. So we can find potentially deep vulnerabilities, but we won't find the kind of vulnerabilities that are triggered by malformed inputs. So in this sense, metamorphic testing can be useful for testing things like the Chrome web browser in a complementary fashion to more traditional coverage-guided mutation-based fuzzing approaches. And we've been using graphics fuzz with the cluster fuzz team to find various WebGL vulnerabilities, like this one here that's briefly reported, a heap buffer overflow that was found by ASAN. And this one, when these bugs are fixed, after enough time has elapsed, after enough time that most users should have updated to a version of Chrome that isn't vulnerable anymore, these bugs get made public. And the final thing I wanted to say is that a nice property of this metamorphic testing approach is that the fuzzing tool actually tests itself. So when we run graphics fuzz and we look at results across a range of different platforms, I just made up the platforms here, but say we had a GPU from ARM, Intel, NVIDIA, and Qualcomm. If we find this magic program, variant 3, that triggers a bug in all of those drivers, then it will certainly be the case that this is actually a bug in graphics fuzz. Graphics fuzz will have generated, due to a bug in the tool, a variant that is not equivalent to the original. And thus we get the same, what looks like a bad image, but it's actually the correct image for that variant across all of these different drivers. So if you want to know who fuzzes the fuzzer, well, the fuzzer fuzzes itself. So in summary, graphics fuzz is a metamorphic testing approach for graphics shader compilers. It generates families of equivalent shaders using semantics preserving transformations. And we've been using this for several years to find bugs in many GPU drivers, but it led to a startup company that Google acquired. And we're now mainly using it to find bugs in Android Vulkan drivers. When we find tests that expose bugs, we can add those to the Vulkan compatibility test suite to defend against them returning, and also to force phone makers to roll out fixes for those bugs when they update older devices. And somewhat surprisingly, graphics fuzz, even though it wasn't designed for this purpose, can find WebGL vulnerabilities due to the property that valid inputs generated by metamorphic testing can go deep in ways that typically invalid inputs generated by more naive mutations can't. As I mentioned, these approaches are complementary to one another. So what about the future for this project? Like I mentioned, testing via cross-compilation, where we fuzz at the level of one language and cross-compile into another, has some advantages, but it also has limitations in that we can't get good coverage of aspects of that lower level language that the cross compiler can't target. So we're right now working on direct fuzzing for Vulkan. We're always looking at ways to make the approach more automatic so that there's less and less manual effort involved in setting off fuzzing, monitoring it, triaging bug reports, and making these compatibility tests. And something we'd like to do at some point is look at fuzzing, not just at the level of the shader programs given to the shader compiler, but at the level of the whole command stream that gets fed to these graphics APIs to find vulnerabilities elsewhere in the graphics stack. Okay, thanks very much for your attention, and I'd be delighted to take any questions.
Thank you, Alistair. That was great. Okay, I can open up the floor for questions. I could even, I'm dying to ask a few myself too, but I'm making sure that I've got, if anyone wants to hit the chat. But in the meantime, Alistair, I'm just wondering, you know, many things, but your journey is maybe the modern journey of the academic. Like I'm not sure, but it does seem like there's so many exciting things in what happened and twists and turns with NDAs. And so I'm wondering if you could just comment for all of us, you know, older academics or the ones that are just graduating soon here in the doctoral symposium, you know, from your takeaways, is this something that you would really, it sounds like you're recommending it in a way, like this is a fun part of the journey, or would you say, well, look, it happened and it was really interesting, but I'm not sure that I recommend it.
Well, actually, what I think is the wonderful thing about academia is that there are so many ways to be an academic. And I truly think that's something that you maybe don't appreciate when you are an academic. But, you know, part of what's been interesting for me about, because I'm joint between Imperial and Google now, and it's been interesting doing both. And I think, you know, I've got a great taste for the industrial side of things, but also it's maybe appreciates, you know, some of the things in academia that maybe I didn't appreciate as much. So two parts to your question, two parts to the answer. One is, I wouldn't recommend it to everyone. I find it really fun. It was kind of an accident, as I tried to illustrate when I went through the, you know, the story. But I think rather than saying you should try doing a startup, I would say, if you are an academic, especially if you have, once you manage to get a permanent position, and in the UK, we don't have to go through tenure, we get like these nice permanent positions from, you know, from the day you get it. Or yeah, once you've got tenure, say, if you're in a country that has that, really think about all the things you could do, and don't try and do all of them, but try and do the ones that excite you the most. So if you want to write a book, do that. If you want to become an LLVM wizard, go do that. If you want to do a startup company, go do that. Do research, do a really good job of your teaching, but do explore the opportunities that you can do as an academic that most people in most jobs can't do. I guess regarding doing a company, it's quite stressful. So it's been really fun doing it, but life's a big balance and trade-off. And yeah, it's been kind of energy sapping being an academic, doing the company, doing the negotiations to sell a company, which are time consuming and non-trivial, as well as, you know, family commitments, et cetera, et cetera. So I wouldn't say it's something that you can just kind of, I guess I did do it in my spare time, but I had to sacrifice many other things to do it in my spare time.
Right.
Yeah.
That's great. Thank you very much. And I think Emma's got a question.
Yeah, thank you so much for the talk. It's very interesting. And having been at Google for a number of years, I'm kind of curious how your day-to-day, you know, how do you balance these two roles that you have? Do you still teach, but you go to the office in London or some other place and sort of code some days, or what does it look like?
Well, at the moment, I just sit in this room all the time.
Oh, well, of course.
But what I've been doing before COVID was 1 day a week for Imperial, but rather than doing it like rigorously on a specific day, spreading the time through the week. So I got some fixed time. I go there to see students. My teaching is compressed into a particular part of the year. So during that part of the year, I'd go there more often. And then the rest of the time, I would commute to London. So I typically use all my commute time to kind of get on top of my academic work and work on papers and work on teaching materials, etc. Yeah.
Great. And we have another question, Arnav.
Thanks for the nice talk. It was really interesting. And actually, I was interested in it because I worked with metamorphic testing before. And yeah,
cool.
Paper on the testing, using metamorphic testing to test basically machine learning implementation. So basically, my question is a bit detailed. I wanted to ask you that the metamorphic relationship that you have considered here. So how do you decide that? Is there any particular way of deciding, or is there standard metamorphic relations in testing compilers, or yeah, how you decide which are the metamorphic relations you should consider?
Thanks for the question. The top level metamorphic relation is simply that on equivalent programs, the compiler should generate executables that yield the same output. So that's the kind of top level metamorphic relation. And then there's, I suppose, an infinite set of things you could do to make equivalent programs. So I suppose maybe your question is more about how do we decide which transformations to apply?
Yeah.
Yeah. Well, there are three ways. One is inspiration from previous work. So that PLDI 2014 paper I mentioned that inspired getting into all this stuff made the point that control flow related bugs were quite common in compilers. So one of the first things we tried in our approach was things like injecting some code that would be unreachable and then having return statements in that code or breaks out of loops from that code. So complicating the control flow graph of a function in ways that make it be radically different from an optimizing compiler's point of view, but don't change the semantics. So inspiration from prior work is one way. The other thing is talking to compiler developers. So when we joined Google, we got access to a lot more people who work in the world of Vulkan and OpenGL, and they would say things to us. Oh, I remember a bug that involved blah, blah, and blah. And we'd think, okay, yeah, we could implement a transformation that involves blah, blah, and blah. Okay. But probably the biggest deciding factor is how easy these transformations are to implement. So in a tool, you can look at a language specification or just have an idea and think, oh, it would be so easy to just swap the order in which functions appear in a file. Very unlikely to trigger a bug, but trivial to implement. Let's just add that to the tool, right? So anything that you can just throw into the tool because it's really easy to implement, you may as well throw in. And then you have things that are a bit more challenging to implement that involve a bit of nice, fun compiler analysis, and you can do them. And then you have things that you implement that are as hard as building like a proper parser and an optimizing compiler. And usually then they're not worth implementing because you don't know in advance whether they'll find anything. It's sure that they're going to be buggy and you're going to spend a lot of time thinking you found driver bugs, but actually turns out there's a bug in the testing tool. So yeah, combination of prior work, suggestions from people in the know, and just having ideas and deciding which ones are just no-brainers to implement versus which ones would probably be a lot more work.
Cool, cool. Thanks.
And I think we have some advice from Ben coming in now too.
No, not advice. Actually, a real question. Alistair, thank you for a very motivating and inspiring talk. I took a few notes on the side, actually. I was asking myself, I never thought of fuzzing graphics drivers, and it's a brilliant idea. If you could look 5 years into the future, what would be the next thing we apply fuzzing to with a similar impact? What do you think?
Well, I'm not telling you because that's what my next startup company is going to be based on. No, I'm
Damn.
I don't have a particularly good answer to that. I think there's a lot of scope for trying to apply fuzzing to machine learning because, and I think people are doing this already, looking for, in adversarial machine learning. I don't know too much about it, right? But like, I think there's a lot of scope for saying, we've got this machine learned, this machine learning system that can recognize things of this form. Why don't we fuzz things into a whole load of forms that should be, equivalently easy to recognize and make sure it can recognize them? That would be like I think people are already doing this kind of thing. A few years ago, I was thinking, maybe I should try and get into that too, but I haven't. I think that media processing. So if you think about like web browsers, more and more they are running rich content. And I think if you can fuzz that content and find vulnerabilities in the kind of media players that everyone is using all the time. That could be pretty interesting. Again, people are working on that, but I wonder whether this validity preserving mutation is something that people have not looked at, right? So just taking a video file and mangling it, yeah, people are doing that, but like looking actually at what the video format is and trying to do interesting, valid transformations on that format, and then maybe mangling them a little bit, that could be interesting. But frankly, I like want to work on something different. You know, I mean, I want to see graphics fuzz through, but part of me is longing to get back into formal verification and more theoretical work and prove some theorems, and maybe no one will use my stuff, but it's like intellectually very satisfying. And going back to what I said about academia, I think it's wonderful that in academia, if you have a secure position, you have the freedom to go and explore these things for their own sake.
Very interesting. Are there any other Zoom questions coming in for Alistair? Maybe I have one quick last one, and then maybe we could take a little break, and then we'll do the roundup. But just curious, Alistair, about the students that you're working with. Do you get a lot of students that show up and go like, "Okay, great, I want to work on this," because you're so well known for it, or are you still getting a lot of students that kind of are coming in for the more traditional formal verification supervision that you?
Actually, the thing that was hardest for me about joining Google was trying to not let my students down. So as soon as I was able to tell them what the plan was, I worked to kind of come up with good co-supervision relationships with some colleagues so that they would have people who were available more than I was, and very specifically not to take on any more students. So I've been letting my academic pipeline flush a bit. I'm about now at the point where I probably would like to take on some more people, but at first, I think it was like hard for me and hard for my students, but hard for me to cope with what was a lot of work for me, and hard for them to cope with not having nearly as much supervision. So yeah, I haven't had, but actually I've always found it hard to attract students, always. And I think even at a university like Imperial that has a pretty good reputation, it's difficult to get good students, especially in programming languages, which is, I think, you've got to kind of get the PL bug. It's not easy. It's like one of the harder areas of computer science. And once you understand how amazing it is, you don't want to do anything else. But a lot of people are into machine learning these days, or in London, there are all kinds of very interesting industrial opportunities that people can take. So yeah, attracting students has never been something I've found easy. I always feel very privileged when a good student does approach me and I'm able to attract them.
Exciting. And I think we have Doug with a question.
Yeah, it's a half question, half comment for Ali. So I think one commonality is that if you're in PL/system/SC, something you do in your life will be a little disruptive. It'll be overhyped, or it'll involve working with companies, or it'll be something that's just not classically academic. And we don't prepare students whatsoever for that to happen unless they happen to be working with somebody who is in, one of those categories. I don't have any good suggestions, about what we could do. But any thoughts, Ali?
It's difficult because I agree with you, but it's not like we can predict what this disruptive thing will be necessarily.
Yeah.
What I think, the only thing that springs to mind is if you do work in a practical area, I think that engaging with industry via, say, reporting bugs or patches to open source software, or, unless you've got a reason not to, like we did initially with graphics, I was making your stuff open source and trying to then collaborate with people who want to contribute to your project. I think that open source is quite a good way to cross the academia industry gap. And I think that's the only idea I have, really, just making sure that people are pretty confident doing somewhat professional software development using, which I think most PhD students are these days, but I certainly wasn't when I did my PhD, using a lot of these platforms and frameworks and being used to code review and all that kind of thing.
Thanks.
But yeah, I don't feel that's a very satisfactory answer. So I don't think I've got any good ideas there.
Better than I would have done.
Well, Doug, I was going to say, do you have a comment from your own experience?
No, it's, you know, what I asked was sort of a generalization across our experiences is that it's so hard to predict that, you know, you're doing what you do and suddenly they want you speaking in front of 10,000 people, or or some company wants to talk to you, or you get called up by the New York Times about the political intrigue of corporate warfare associated with what you're doing. Yeah, I lived through all those things. Yeah, nothing prepares you for that. But I think people in this, you know, ill-defined realm of PL systems, SE, we're prone to it. You know, it's inevitable. You're working in these kinds of areas. Somebody's going to be paying attention someday. And if you could guess what it was, well, you'd probably be off doing it instead.
Exactly. Well, that's great. I noticed we're almost at the 2 o'clock hour where we were maybe going to have this academic panel roundup with the great people that contributed to help all the students today. Maybe I know that we have a number of people on the list. Maybe I was going to say, I mean, whichever order you'd like to go in. I think Emma, if you wanted, you could kick us off with your closing thoughts. This is a quick session where we're just going to go through some closing thoughts from academics that helped out today. Sorry to put you on the spot, you know. We can pass it back over to Alistair or Doug if you like.
It's just that it's noisy here, so give me a couple of minutes.
No worries, absolutely. Doug?
Oh, me, jeez.
Sure, if that works for you.
Sure. So my first thought was I've been involved in a fair number of doctoral symposia, and I have never seen such smooth talks and interaction. Really, well done, guys. This was a pleasure to be involved in. I felt like usually people can be like given like really basic pointers about presentations and things like that. No need today. So my main thought is everybody who was involved in this doesn't really need our help.
We need them more than they need us.
And literally, that was the only thought I jotted down all day, knowing that I would be put on the spot here.
Well, that's great. Thank you for your participation today, Doug. That's fantastic. And maybe Christos.
Yes, hi. I had an excellent time today. I really enjoyed the student talks. I learned a lot. And congratulations to everybody. I think this is great work. Keep going. And I'm looking forward to reading your papers in the near future.
Absolutely. Thank you, Christos. And maybe Ben.
Of course. So I'm used to having long days at conferences. So this has been a particular long day. So I got up at 7 or so, and now it's 11 p.m. here. But a little bit reversed. Usually you get the conference in the morning and then talk with the colleagues at the end. But I agree with Doug. So this has been a very interesting and pleasurable experience watching all the students talk. They didn't need much advice from us, interestingly, this time. So I'm wondering what this will do to the format of doctoral symposium if we have such good students already. Let's see. Let's find out. I learned a lot also from the students, from all of my colleagues. So it's been a great experience, and you're all on a good way. So keep up.
Fantastic. Thank you, Ben. maybe Emma, if it is a good time, we'll catch
This is typical Corona setup here with kids that don't want to go to sleep and everything. Yeah, can you say that I really enjoy to get to hear about all the great work you're doing, and as Ben said, yeah, you seem to be well on your way here. So I hope we could contribute, or I could contribute in any way with my questions, and I really look forward to see what you publish in the future. And thanks for letting me be part of this as well. It's been really interesting.
Great. Thank you, Emma. And I think last on our academic panel was our last speaker, Alistair, if you have any final thoughts for the students.
I really enjoyed the presentations too, and I thought that you did a really good job of answering questions. It felt like engaging at a regular conference or workshop in terms of, you know, some really good research being presented, being very clearly presented, and then having strong and thoughtful answers to our questions. One thing I might say is that I think that the students possibly could have asked more questions of each other. And going back to some of the advice Ben gave about promoting yourself, Ben, I had a bit of childcare going on during your talk, so apologies if you made this point, but actually asking questions is a good way to increase your visibility. So one of my colleagues, John Wickerson, tries to ask a question at every talk he attends unless there are loads of questions. And so I would say that, yeah, I think that you're behaving like very mature researchers in terms of the work you presented, the way you've answered questions. And I think one way to maybe grow maturity is to get creative about thinking of questions that you could ask. I think it's often really nice for your fellow students or fellow conference attendees to get questions about their work. So don't be shy and put yourself out there and do it. But yeah, congratulations on really good work. It's inspiring to see.
Absolutely. Thank you very much, everyone. I think I'm going to turn over to my co-chair from Splash, Matthias. I wasn't sure if there was any formal ending that you wanted to do here, or if any of our other wonderful co-organizers. We almost outnumbered the students with organizers, which is pretty deadly. But I really want to thank everybody that worked so hard, for sure. And certainly all the students that put great effort into these slides. I agree, those talks were amazing. I really enjoyed it. Matthias, do you have anything you want to close with?
Yeah, I have a couple of points, but then I would like to give the word also to our co-organizers from eCoop, who did a tremendous job. They did most of the work here, okay? So they really deserve a lot of thanks. But before I go there, I wanted to bring up a couple of points that stuck with me. First of all, I really liked the presentations. I think they were of a really good quality by the students, but also the presentations of the invited speakers. So I need to steal your talk, Doug, and I need to use that to help me advise my own PhD students. I think this is a talk you should actually also give to faculty, not just to PhD students. It's top, and I think Nafisa, I think, recorded it. I made a mistake and didn't start the recording, and I told everybody it's not recorded, and I hope we have a recording.
Yeah, I have to say, I'm sorry because not filling the consent form and everything, and previously asked the speakers if they want to be recorded or not. But we took the liberty to record the talks from our amazing academic panel. I hope it's fine with everyone. They were so valuable that we thought to keep the recording and upload them somewhere if everyone agree with this.
That's good. Let's make sure in the end that Doug and Alistair and Ben all agree, and then we can look how to share. The last point I wanted to make was about Alistair's and then also Ben's. I think it was a nice combination. I mean, all the three invited speakers were organized by your eCoop chairs, and it's a really nice combination because it's this trio with different perspectives. And Alistair's kind of how to transfer to industry, I think, really was an insightful thing also for me, because I've never done this, and I don't know whether I will ever be able to or have the energy to do this, but it sounded very interesting. And then Ben, with the marketing, the thing that stuck out to me as a former artifact evaluation committee co-chair was I really liked that part that you stressed the importance of doing that. And I wanted to add one quote from the survey we did at UPSLA 13. So we asked the authors, in addition to the artifact evaluation committee members, but we asked the authors of the papers, how did you like the reviews you got from the committee? And the committee was essentially PhD students, right? And so we asked, and we got this thing, and I need to quote that. I still have a Google form here from those days. I just need to find in my many windows. It's all kind of gone right now. Oh, here we are. So one answer was the reviews are excellent and discovered every problem that we knew about before we submitted. And one of these discovered a compilation problem that we didn't know about, and we're still investigating. And then I find these reviews, the artifact evaluation committee reviews, on par or better than the PC feedback we got at UPSLA. Okay, so I think if you're a PhD student and you're on an artifact evaluation committee, it's not busy work. It's not like, oh yeah, there's also the artifact, but you can do a really good job, and the authors will actually, at least some of them will appreciate. And I know this specific authors because they actually signed their survey response, and it's a very critical, very serious person. So this is not like cheap feedback. And then it continues. The reviews really drove home what we should have done to help the artifact evaluation reviewers with the evaluation, which would also help the XXX programmers with using our new features. So you have an impact not just on I don't know, the authors, but on the systems that they build and on the future users of those systems. I think it's a big, nice statement for doing or contributing to artifact evaluation. With that, I'd like to pass the word to Nafisa, Chengsong, and Philip.
Thank you, Matthias. I'm just gonna quickly add some thank you notes. First of all, thank you to our great authors. Thank you to our amazing programming committee. We had a very amazing PC that reviewed the papers for eCoup. Thank you, every one of them. We had a great academic panel. They paired with us a lot. This was supposed to happen in July, and then everything changed, and so many things happened, and they were so generous and flexible with their time, and they still offered to give their talk and be with us today. Thank you very much, every one of you. Thank you very much, Splash Trace. You helped a lot. This was great. This was so much fun to work with you. And the whole thing was so much fun for me. I enjoyed it a lot, and I learned a lot. Thank you, everyone, again. I don't know, Chang-Sang, if you want to add a word or something. It was amazing from my side. Thanks, everyone.
Yeah, thank you, Nafis, as well. So, yeah, Nafis just basically expressed the thank you words I want to say as well. So it's really very, very inspiring experience for me. Very good people are researchers. And you're very generous about your time, and I'm really, really inspired by not only the invited talks but also my peers. I'm astonished by the amount of work and the presentation, and I would say I'm really inspired, and I hope I could work harder and to advance in the academic field. So really thank you, everyone, and I really got inspired.
Well, thank you very much to all the organizers for making it happen. Much appreciated.
Oh yes, there is so much work. Thank you so much.
Thank you.
Matthias, I have a question. Is the expert that you read from 2013 or from the 2013 OPSTA?
It's from 2013. At least that's what the
okay.
folder is in which I stored it. I hope I was on both 2013 and 14.
Okay. Okay.
So
13 was the first in PL. Great.
Yes, it reminds me of something. That's why I'm saying that.
It's not yours, at least.
Okay.
Okay, everyone, I just hope that we can meet you in person at some point very soon in a conference or somewhere. Looking forward for the next event, and have a good day at some part of the world and have a good night at the other side. Bye-bye.
Bye. Thank
Bye,
you.
everyone.
Thank you.
Thanks. Bye-bye.
Thanks, Matthias. That was fantastic.
Great.
Thanks. Bye.
Bye.
Bye, everybody.